Welcome to episode 6 of Tacit Talk. My name is Conor, and this is the first ever implementer panel. We have with us 4 different language implementers. I'm going to read, or I guess you are seeing what I'm seeing, so I'll go clockwise, starting with Elias. And these are all the first 4 guests from episodes 1, 2, 3, and 4. So we have Elias representing the CAP language, Kai representing Uiua, Adám representing Dyalog APL specifically, and then Marshall representing the BQN language. How is everybody doing today?
Awesome.
Great.
Good. Great. Nice.
All right.
Thanks.
Yeah, this
I'm
is
great.
Gonna,
it's 7 a.m.
Oh, yeah. I mean, we could, maybe people are curious. We are across the globe here. I think we're spanning, 15 hours? So I know Marshall and I, we're both on the East Coast. Elias, you're in Singapore, correct?
Right.
Which is
UTC +8.
Yeah.
So
UTC,
it's 10 o'clock here now.
Yeah, it's quite late. So 12 hours ahead.
Which 10 o'clock?
Yeah.
22.
Yeah, we've got 10 a.m. and 10 p.m.
10 o'clock here, but
Yeah, 2 different 10s. And then Kai, we've got you on the West Coast, correct?
yes.
So yeah, it's rather early for Kai and rather late for Elias, and just perfect for. And Adám, I guess we skipped over you. Are you in Denmark right now, or are you traveling?
I am. Yep, Denmark, UTC +2.
Okay, so that is that 5 hours
It's
ahead?
4 o'clock in the afternoon here.
Okay. And for posterity's sake, I realize I usually do this on my other podcast, ADSP, but I don't do any editing for this podcast. So usually we don't end up saying the date, but today is October 22nd. If you are listening to this in the future, 2024, I should say. Halloween is a week away. And this is going to be a little bit of a different episode. So the first 5 episodes, if you include the one with Zach Smith on combinatory programming, were one-on-one interviews talking about a specific language or specific topic. This is going to be a conversation where I get to ask questions, and even if the 4 of you want to ask questions to each other, you're more than welcome to. And if you are watching on YouTube Live right now, there is a chat section that I will be monitoring if you have questions for any of these folks. And we're going to talk about things related to implementing and designing an array language. So I have a first question. I guess maybe before, I will assume that most folks have watched the episodes 1 to 4. Maybe pause this if you haven't to get a background on each of the array languages. But of note, CAP, I believe, is written in Kotlin. Uiua is written in Rust, and then both Dyalog APL and at least C BQN. I'm not sure how many other BQN implementations there are both written in C. So keep that in the back.
Well, it's a bit of a misnomer.
It's a bit of a misnomer. Should we clarify?
Well, yeah. So it is at the end of the day built with C, but there are large components that are written in BQN and Singeli. So.
Okay.
It's not just the pure C BQN. And yeah, I don't know how many BQN implementations there are either, because, not everybody who does one tells me.
This is true.
That means you reach critical mass.
Maybe. I mean, is it critical mass if you don't even the people building an implementation have to interact in some way for there to be a chain reaction, right?
I think you reach critical mass once things happen that you're not aware of.
I don't know. I think you reach critical mass where, if you emit a BQN, then somebody standing next to you will then emit 2 BQNs. That's and
It never blow up on you.
The problem is with that method.
Yeah, I'm not sure we want to reach critical mass is the thing. Yeah, BQN's goal is definitely not to be the most popular language out there.
And the thing is too is how do you know if the goal is to have people doing stuff that you don't know about? At some point you have to know about it, right? So maybe all these languages are in that twilight zone of people doing the stuff, and it's going to take a year or two, before you find out that people were doing stuff that you didn't know about. It's a catch-22.
Okay, maybe I used the wrong word. Maybe it's not critical mass, but it's because it's not a goal, but it's you've certainly reached some point, some kind of vital spot when things start to happen without you. What?
It's no longer a massless programming language.
Yeah.
Which also
And
means
now
you
you have
can't
to
move at the
care
speed
about
of light.
compatibility and things like that, and that sounds horrible.
Yeah, it weighs you down. It's got inertia to it.
Okay, well maybe we'll come back to
Yeah, were we going to start this podcast at some point?
we're live, so
I-
it's definitely.
I know we're
By the way, I
live.
think I can
I don't
correct
think
the
we
thing.
started.
Dialog is not in exclusively written in C. Some of it is C++. Some of it is written in Dialog APL, and as well, which is interesting.
You have,
And I think there's
you
a
have
little bit of
C++ as
assembler.
well?
Yeah, some part.
What are you reaching
And-
for C++ for, or is it is trade secrets, or we're not allowed to
Templates,
know?
pretty much purely templates.
Interesting.
Yeah.
Okay, well, I mean, I had a question, but we already have a question in the chat, which is a pretty good one to start with. So, from EK says, "What's the hardest, most conventional decision, or controversial?
Controversial.
Controversial, maybe
First-
controversial.
Probably controversial. Yeah.
Hardest or most controversial decision you had to make for the sake of your language. We'll kick it to whoever, because I can see the gears turning. Whoever has an answer first, and then maybe we'll just.
All my controversial decisions were so easy. Like having a garbage collector. For some reason, that seems quite controversial, but I was like, yeah, of course the language has a garbage collect. I mean, like allowing mutable references, so you have to collect them. And then all the K people are telling me, K and J people are saying, no, you should never allow circular references in the language, so you don't have a garbage collector. I'm like, well, we'll just implement a garbage collector. I mean, that's something the programmer doesn't have to worry about.
So what is the syntactic spelling of the mutable reference thing? Just so that we,
I mean, there's no
syntax for
specific language construct for a mutable reference. If you have any form of mutable data at all, and that includes function closures, then you can form reference loops with it by programming with these in a particular way. So a function closure, like if you write a function that returns a function that uses a variable in the outer function,
right?
Then that inner function has a reference to the outer variable. And of course, the outer variable can have a reference to the function or other stuff. I mean, so you can have, functions that mutually reference each other and all that sort of stuff. And therefore, just reference counting is not good enough. It'll give you memory leaks. So you have to have some people consider reference counting a form of garbage collection, but you have to have a tracing garbage collector or something that can account for reference loops.
Yeah, there are some cycle breaking techniques you can use as well that I've seen it used, and it's usually only so Kotlin used cycle breaking garbage collector before for the native backend, but they threw it out and replaced it with a proper garbage collector because, as it turns out, since the 60s, we've known that the proper garbage collector is pretty good. And
yeah.
All right,
I
so
just
maybe
didn't want
we'll
the
separate.
garbage collector.
Or sorry, go ahead, Kai.
I was just going to say, I saw the problem of, then you'll have to implement a garbage collector. And I said, yeah, I'm not going to do that. We're going to reference count everything, no cyclical references, everything's fine.
Yeah, I mean, and you don't have first class functions, so you don't have the closure question. I mean, I think it's reasonable for some languages, but I mean, the idea of BQN is just to have the nice facilities that you have in a typical scripting language, and also array programming. So it seemed kind of obvious. And yet,
if we're talking contraventional, I mean, mine's probably the local variables, right? No local variables.
I would have thought that the removal of first class functions would have been the most
APL and
controversial
J
thing.
don't have first class. I guess it depends on where you're coming from, right? If you're coming from APL and J, it's not very controversial. But if you're coming from I guess everything else, then sure. But I think I've been pretty convinced that you never need functions with an order higher than 1, right? Or higher than 2, whatever you would call a function that calls a function or returns a function, right? I don't know that you ever need functions that return functions that return functions.
Well, I mean, all you need is a tape and the ability to move back and forth and write stuff.
In expressing your ideas,
all you need is SKI calculus, and then it is all
You know what
its
I
functions
mean?
all
It's
the way
like
down.
it's the stuff that you need, the stuff that you want, right? You never want functions that take functions that take functions that take
Well,
functions.
speak for yourself.
Do you have a practical example, Marshall?
I mean, I have a lot of them. So I mean, it does show up in more complicated code, so it's hard to get an example that's simple enough. But I very often, like, if I want to choose between different things to do, an array of function is often a natural way to do that. So I mean, I'll have, you know, I'll have my set of arguments, and I'll have one function that does one thing and another function that does another thing, and so on. And then I'll select which function I use. Another thing I can do is to like build up functions. So if and I don't know if I have a great simple example of this, but a lot of the time it's useful to say, you know, I have these different pieces of functionality, but the actual function that I want to return is this function combined, like composed with some other function afterwards. Actually, a good example is the my wave file reader writer for doing stuff with music. So it has wave files can have various formats for the audio. So you might have integers of different widths, and there's a floating point. So what I do there is I have I think it's a modifier that returns a function. So it takes the format in, and it returns you a function for working with that format. And then you can apply the function to decode a wave file, or you can apply its inverse to encode a wave file. And with first-class functions, I can share a lot of functionality between those functions that it returns. So like actually for all the integers, it doesn't just have a function written out, one for 8-bit and one for 16-bit and one for 24 and 32-bit. Instead, it constructs a function based on the integer width you give it. So that ends up being pretty clean in the code base.
All right.
And yeah, there are parts of that are invertible and parts that aren't. But so by making the invertible part into a block function, you can have that declare its own inverse, and then the rest of it you can write tacitly, and that'll be inverted automatically. So you only have to invert the parts that are too complicated for BQN to do on its own.
Okay, so we have implementing a GC, most controversial thing that BQN did potentially. I don't know. It sounded like
I didn't say most controversial, but it's
one of the many
it's probably
controversial.
the biggest gap between difficult decision versus controversial decision.
Right. And then Kai, you said the lack of local variables, like purely tacit. What about CAP and Dyalog APL?
Well, I think probably the original choice of implementing the whole thing in Kotlin was never it was never a plan. My first prototype was in Common Lisp, and then I actually considered doing it in C, and then I realized that hey, there's an alpha. At the time, it was like a beta or alpha release of the native compiler. So I figured, okay, why don't I just write it in Kotlin instead? I can just compile to native. So the first version was just compiling to native to native code. And then I realized that adding JVM support was trivial because it's the same. I just needed to write a little bit more glue code on the Java side. And then I realized that running it in Java was 10 times faster. So, or at the time it was more like 100 times faster. Actually, it's around 5 or 6 times faster. But the compiler at the time was so bad that it was kind of pointless to do it natively. But I kept the native version, and it's still there. And now the Kotlin native compiler has caught up. So now it's about 5 to 6 times slower in your typical case.
Are you saying the native compiler is still 5 to 6 times slower?
Yeah.
Isn't correct me if
and
I'm
the-
wrong, but isn't the idea of like compiling to native is that you're supposed to have like a perf win, or is it not? That's not
No,
the
I
use
mean,
case?
I mean, you get phenomenal performance actually out of the thing, thanks to mostly thanks to the JVM, because the JVM is so good.
I was gonna say the JVM's been optimized for like 30 years, right?
Yeah, exactly. And compiling to native is, I mean, there are many reasons why it's slower. And to be honest, I don't know most of the reasons. But yeah, so controversial. Yeah, at several points I was thinking about going back to common Lisp because it's more fun. Maybe rewrite the whole thing in something else. But then I realized that the Java version is so good that there really isn't any choice, especially if I want to be able to easily compile to JavaScript and natively as well. But maybe not. So the decision might not have been controversial from the outside, but I was racking my head with this for quite a bit. So personally, it was very controversial to stick with Kotlin. But I mean, now it works pretty well. Yeah.
How far did you get into the common Lisp implementation before you switched?
It wasn't far at all. It was a prototype. It didn't even have a parser at the time. So to write, you have to write the code as Lisp expressions, which is fine. So maybe it was 1,000 lines of code, something like that. No more than that. So it wasn't very far off. And then I shelved that, let it sit for a year, and then I restarted the project again back in 2020, and yeah.
All right, last but not least, Adam, you've had the most time to think.
Yeah, I also need the most time to think, given
The most time under development.
Yeah, exactly. But my role in development is, if you take this as a personal you as opposed to as a company you, then my role in development is very different than the other people here on the panel, because APL in itself is pretty nailed down at this point, or should we say the APL2 style APL and Dyalog APL even more so nailed down. The only things I can have influence on are really additions, and if you look at what has generated the most discussion in the company, then it's been naming, and naming of things, whether it's a system function, so these English names or abbreviations for things that are like outside the core language, or even which symbol to give new language elements, new primitives. But there aren't really any huge like architecture, how should the whole thing work questions anymore.
Oh, you did total array ordering. I was just
yes,
Wiki's stuff on that, because
that's very good.
They're adding their own versions.
That's true, but I don't know.
I have to say that thing is not controversial though. It's
No.
very
The existence
natural.
is not controversial.
I wouldn't call it controversial as much as there was a lot of discussion. There's so much discussion in email threads that my email client gave up on keeping it as a single thread 3 times. It started a new thread because every time we had 100 emails in a thread, it just gave up on keeping track of everything and started a new one. And we were very close to giving up entirely on the whole project. And there were lots of like gotchas and things. I think the result was very good. I'm very happy with it, but I don't think it was really controversial. It was just hard work to come up with something.
Yeah, that was the first part. Hard decision.
Yeah.
Okay, yeah, so you're right.
We
so
can,
I
we
think
can split that there's kind of 2 different questions that can be answered. One is
everybody's been
hardest.
doing controversial things, but the hardest one for sure was the total array ordering, or almost total. The most work, the most brain wrecking, the most people wanting to just throw their arms up in the air and walk out and just give up on the whole thing. But controversial has only been, I things like naming it. It also took us forever to find the right symbol for stencil, but then it was completely non-controversial. It's like, yeah, that's it, that's the one. Whereas something I remember very vividly was we have this system function to convert between date-time formats, and it ended up with a name quad DT for daytime. But gosh, did we have a lot of discussions about that name.
I have some opinions on that name. You sometimes I'm glad to not be working at a certain place. If I had been there, that's one of those things. I have a pet peeve about that name.
Okay, well, I maintain that that it's not specifically dates. The word time is the indicator for a moment in time that it deals with, and that's the letter that's used in by SI and ISO. So I said it should just be quad T, and some people say, yeah, but DT is the normal abbreviation for date times. But it's really a conversion function between date time representations or time representations. So we have something called quad DR for data representations that converts between different representations of data. So this should be quad TR time representations, and
it must have a C in it for calendar.
Because it's, well, maybe it should be quad Gregor or something like that, because it's all based on the Gregorian calendar. But it's not that either, right? Because some of the formats it deals with are not calendar based at all. Right? The Linux timestamp, epoch time, Unix time, sorry, it's not, doesn't care about the calendar at all. It's just count of seconds, almost count of something we call seconds that don't correspond to SIC. It's complicated, right? Those kind of things is where we had tremendous discussions about, and where internally there's been controversial certain of the decisions we made. Externally, I don't think there's been anything since I started.
All right, so now I think we're gonna pivot, although it is kind of on topic because you mentioned naming, and it made me think of what my original question that I kind of wanted to discuss and see where this went is, famously one of my biggest complaints about Dyalog APL, although it might be coming in a future 21 or 22 edition, is there's no sort primitives. I think of the, actually no, wait, I know that Uiua also doesn't have. Last time I checked, I know we talked about it, Kai, and then you said you were close to putting sort primitives in.
Uiua has sort experimental currently.
Experimental. Okay, so it's on the precipice of getting in.
But the experimental part is not the implementation; it is whether it belongs in the language.
Right. So yeah, for folks that don't know, there's a experimental button that you can click on the Uiua pad to get access to extra glyphs that aren't fully in the language but are being played around with. Marshall, you were going to say something?
Yeah, so you've also got J definitely has no sort function, and most versions of K don't. Some of them have the caret for sort ascending.
Okay, and Cap at one point didn't, and then I think I complained about it on Twitter, and then Elias put it in, and I even forked the repo, and I called it Cap plus plus, because not as like I was actually gonna develop it, but I wanted to see if I could hack it. But before I was able to actually, I think I tried for 10 minutes. But by the next day, it was already done. But this brings us to the question, which is, what goes into choosing primitives? Because I think across the 4 languages that are represented here, I don't know what percentage, but we'll say 75%, 80% are the same. But there are definitely differences. When I'm in BQN, one of the biggest ones that I miss coming from like Dyalog APL is the encode and decode ones. When I'm in Dyalog APL, I miss the sort ones. And then I think Cap has, correct me if I'm wrong, but you have chosen different definitions for the take and drop. And I think the same thing actually in BQN. BQN, the monadic ones are prefixes and suffixes, I think, which is like the equivalent of tails and inits in Haskell, if you know those. So it's like scans where you're using catnate as the binary operation. And then in Uiua has
Nah, not quite.
Okay, well, modulo the details, but you can get something similar.
Oh, there's some pretty big details there. It's like in all but one case, it's not that. But okay.
Okay. Well, so it sounds like it was completely wrong. But just to round it out, and Uiua has a
It
whole.
is the same idea, but it's just that that it's catenate scan is not a good implementation of that idea.
Right. But yeah, and Uiua, just to finish the thought, is that you don't have overloading of the symbols, which means you have to have twice as many symbols if you want to replicate, one-to-one what exists in the other languages. So there's some choices where I'm pretty sure there's no logical and an or. So if you're doing a logical and reduction, the pattern is to make use of the min and max glyphs, which in the space of Booleans is the same thing. And I think that actually kind of mirrors what happens in Q. So that long-winded, explanation out of the way, what goes into, deciding whether a primitive should be in the language? Like, do the languages, as implementers, do you have different philosophies? I'm going to stop talking there and just kick the ball to the four of you, and I will now just listen. So who wants to go first?
Marshall did a write-up on this, right? Yeah.
Purest philosophies.
Adam
right?
volunteers me. I do have the write-up. Yeah, so I have a page. Specifically, the title is "What is a primitive?" So this doesn't necessarily tell you which primitives to choose, but it tells you a criterion for whether you can choose something as a primitive. Sort of. I mean, not a single criterion, but sort of trying to define my concept of which things are valid for primitives. And I mean, I tried to make the case that, there are that primitives are this category of operations that are simple and useful, and that there really is such a category that has, if not a perfectly sharp boundary, something sharper than you might expect. But then you have to choose, which primitives you support. In a lot of cases, there are different, there's functionality that might be equally supported by 2 or 3 different primitives. So you want to choose one of them because you don't want to, just have a whole bunch of stuff that really does the same thing. So yeah, then for BQN, I have my 3 categories of primitives, which are things for working with arrays, things for working with functions, and things for working with numbers, which are also sometimes used for characters. So in terms of how I actually choose what's in there, I mean, one thing I try to do is just aim for the most simple and flexible thing that does the job. So in BQN, I've really tried to be minimal and reduce the number of primitives it has. But also, like, it's not just, it's more about like how easy it is to learn what all the primitives do. So, I mean, if you have sort up and sort down, I mean, I don't really count that as 2 primitives. That's much more like 1 primitive. So I guess just trying to add, the most simple tools, the ones that are least likely to get you into trouble in edge cases to, so if you write a program with it, it's likely to work on all the inputs you could possibly get. Yeah, so the main theme is simplicity, I would say.
Thoughts from the panel?
I agree with all of that. That's what I can say.
However, you disagree with my primitive choices.
They're pretty good. There are some that are unfortunate because they tend to render as emojis all the time.
Oh yeah, I mean, I'm talking about what functions I have, not what glyphs I use for them.
Yeah, no, I tend to simply, if I add something, add it typically using a word. And then if I notice after a while that I use it all the time, then it might warrant a symbol, maybe.
I've done that.
So, yeah, because the most recent thing I added was a proper round towards even. I did that yesterday, and the immediate question on the chat was, so what symbol is it going to get? I don't know if I want to give it the symbol. I don't know how often I'm ever going to use this. We'll see. If I use it often enough, maybe. There are some symbols. I jokingly suggested using the circle because it's round, because obviously I don't have the circle functions. But right now it's just called round, and I think that'll be good for now. And if it's needed, it gets a symbol. So I don't really put any particular value in the symbols other than that they are convenient to write, and they combine nicely in a tacit expression, which words tend to not do. But other than that, it's just a matter of is it used often enough to warrant being a symbol?
I would strongly protest that one, for example. And you said just a normal round to even. No. Part of this, the whole beauty of this, is that you can see directly what's happening, and everything does what it says on the tin. The word round in English does not at all tell you what's happening. What does that mean?
You mean the symbol?
No. The symbol that is shared between BQN, APL, for rounding up and rounding down are very indicative of what they do. Once somebody explains to you that the symbol does this, the symbol does that, you never forget it again. And however, saying something rounds in general with the English word it's round, it is not at all clear. How much to know that it rounds to even? That there's nothing in the word that says that. This is not how they round in the store, right? This is not how people learn how to round in school.
Well,
I don't
but
think
we go into accounting.
Okay, but there's nothing on the language that says, oh, by the way, we use accounting conventions. Also, all your values must have a currency symbol in front of them, right? No, this is not what the language is about. It's more mathematical than accounting. So I would say that's just wrong for primitive. Maybe for a word like that, but it should maybe be like accounting.round or something like that, or rounding.accounting
Well,
or
I mean, I
something.
think so. So I think
mean,
this is
the
a
name.
good point in not giving it a symbol, but in terms of making this be the function you provide, like when it matters, the like other tie breaks are generally a pretty bad choice if the choice of tie break matters, because they're biased. They'll eventually start, shifting up or down if you keep rounding a lot. And so that's why the round to even rule exists. So, I mean, I don't think it makes sense really to
You
provide
can
another.
round to odd as well. Happens to be people use even, but
Well, yeah.
I can tell you that the reason it's round to even and according to those rounding rules is because lifted straight out of Common Lisp, which also happens to name the function round. So that is a kind of a design approach that I have, and that was also what guided the number system, which is significantly different from most other APL dialects, in that it does rational arithmetic, and that also comes from Common Lisp. So I don't think it's particularly controversial to have it called have that function being round, because a round with bias upwards, which is what you get when you do divide by 2 after adding a half. That's trivial to implement without any function. Round to even, it's a bit of a hassle getting it right, so it makes sense to provide it as a function. Now, I personally don't think it should have its own symbol, and I think you were getting at the fact that the symbol round being the circle is a little bit silly, and I agree, and that I probably wouldn't do that other than as a joke, maybe an April 1st edition or something. But if it were to have a symbol, probably would be the one that is a vertical bar with a little line coming out of it, because it's in the middle, in between the round up and round down symbols, maybe. But yeah, I think choosing round to even is not that controversial because there is a precedent set by other languages.
I don't think you could say that choosing this is not controversial. That's you can choose this, and I will protest, and therefore it's controversial, right?
So this
But you're
might
not
be the
front-
best
You're
controversial
not
design
protesting
decision.
that the choice of rounding function is controversial. Would you choose a different
Hold on,
tie-breaking
guys,
rule?
this is about primitives.
You're just
not
protesting that whether it's controversial is controversial.
So wait, what were you saying, Kai? That we're talking about?
Well, I wanted to offer a slightly different philosophy about primitives. And it's basically the ratio of, in my mind, when I consider adding a primitive, right, it's the ratio of how often you need it to how long it would be to spell it out.
So
Right.
this is exactly, I've had this thought in the back of my mind. Like I mentioned the encode and decode that BQN doesn't have. And it's not to say that I'm imploring Marshall to add them, because my solution is that I go to BQN crate, I copy and paste the, getting base 2 or base 10 or digits, and then I put it in a little library file called binary.bqn. But there is this trade-off of like, sometimes it's not about like, oh, I reach for this all the time, but it's like, when I do reach for this, it is the cost of, Aaron Shu likes to say, oh, it's just idioms, blah, blah, blah. But sometimes like the idiom is 20 or 30, like I don't know what the BQN crate is, but it's a non-trivial thing to get digits from a base 10 number. And whereas in APL, it's quite easy because you have the encode and decode primitives. So yes, back to you, but I completely agree that there's something there. Like, what is the solution when you're missing a primitive that might not be as common as reduces and scans, but causes pain when it's not there?
Yeah, I mean, it's part of the reason that I have like an experimental sort primitive, right? That I've considered adding it is because, yes, spelling it out is 3 glyphs, right? 3 characters, but you want to sort things so often, right? And then there's other things like I have a function I call base, which is basically either encode or decode, and then the inverse is the other one. I've considered adding that, but I've never needed. It's very seldom that I need like encoding other than base 2, and I already have a primitive for that. But there's lots of little things like that. I have like stack manipulation things that are a little bit more verbose to spell out, but you want them all the time. And then there's things like partition, right? It's very often, especially when you're trying to parse things out, or even in other scenarios that you want to like do your partitioning. And APL has 2 partitions. Uiua has 1 partition, but the BQN doesn't have any. And then there's the like, how do you spell that out with group? Oh, it's kind of long, and so I thought, no, I want to do this often enough. We're gonna have partition. There's other reasons to have a primitive, but I think that's like my most driving one.
I'm
Yeah,
with
and that to me,
Kai
so like the reason I don't have partition and encode is because they're not. I don't think they're actually individual functions that you can add as primitive. It's a lot like round, where you have different choices, except in this case, the choices are actually like not just these edge cases, but the main functionality. So, like we should add probably to the math system namespace some encode and decode functions, but actually the main barrier to that is that we can't actually decide, what exactly the functionality is going to be. So, so having it as a primitive, I mean, I think it leads to a sort of bad programming pattern where you try to apply the primitive even in cases where it doesn't actually apply, and then you try to adjust the input or the output. And that to me is just not as natural, and it's not as it doesn't give you the same ability to refactor and do proofs with your programs. So I don't think it fits as well into the array paradigm to give these things symbols.
And there's something else that Kai mentioned, things like stack manipulation. And there's I think there should be. Unfortunately, Dyalog APL especially doesn't really make this distinction well. There should be a distinction between the core language, this array manipulation and computation of things, and systemy stuff. And BQN has much the same type of thing as APL has, with some special glyph that introduces a name that is like a built-in name, but it's a name, not a glyph. I think that's a good thing to have for all the dirty stuff, all the stuff that doesn't fit into clean general purpose predictable primitives. And unfortunately, there are multiple examples in APL, and especially Dyalog APL, of that distinction not being done properly. And of course, we can't really fix that because of backwards compatibility. But I think that's another criteria for choosing something to be a primitive. It should be pure, not dirty.
Yeah, I have a lot of sort of, I guess, dirtier functions like that for like image or audio encoding. I have a function, experimental function that renders text. Like you give it a string and it gives you an image back that is the rendered text, but that's never going to have a glyph, right? It's not primitive enough. And there's a million ways you could want that, but it's like, this is powerful enough and it's hard enough to write yourself that it's nice to have something powerful like that in the language. And I don't know, I personally don't like having to import libraries. Like Uiua has library importing, right? But I like when the tools that I want, even if it's like a specialized thing, is just right there for me to have. And that's a very different philosophy than I know a lot of languages take, and not just the array languages.
Yeah, that ties into a question that just got asked in the chat. Is it unusual to have library dependencies to add functions so that you don't need to look things up on wikis and whatnot? Yeah, like how often when people are using these languages, are they doing some kind of import? I mean, I do it all the time in BQN now because, I mean, I'm not sure if you want to comment on your style, Marshall, but from having looked at a lot of the code that you've written, like you have a little library repository on GitHub, and I've just kind of, it's unfortunate that there's no like package indexing.
Yeah, well, I was gonna say, so like that would be the hardest and most controversial decision we've made, is how to do the package manager, except we haven't decided. So
yeah, but that would be like,
how many?
Oh, go ahead, Elias.
No, I was wondering, how many packages do you need before a package manager becomes critical? Because obviously, when a language starts out and you have 3 libraries, a package manager is not necessary at all. At some point, it becomes a pain. But how far, at what point?
Now are using Git submodules for this so I think that kind of delays a lot of the pain, but I think it would become worse if your dependencies had dependencies. So once you get to the point where somebody wants to include a package that itself is including a bunch of dependencies, that's probably the point where there's going to be trouble. But I mean, that's I think there haven't been a whole lot of people, clamoring for a package manager recently, and that's part of the reason, is that Git submodules kind of cover the same ground.
I was using Git submodules, but I moved to just Git cloning, and that can also work. Just so you can have more power, because I don't know, there's tons of times when I import a dependency in the Rust or something, and I want to change some little functionality or implementation of the library. It's nice to have that power.
But then you can't get updates, right?
Yeah, well, I guess the submodule gives you a way to fix a commit, but it's also pretty inflexible about that. So, I mean, you could also have a command that runs a clone and checks out the commit you want, and then it can check like versions and things, so you can write it however you want, but you have to write it all yourself.
I think we can answer the question.
Go ahead.
We answer the question if it's unusual to have library dependencies. Yes, it is, because for all of these languages, there is no well-established ecosystem of sharing libraries in a convenient way, or even if there's a way to share them conveniently, there aren't really that many libraries, so it's bound to be unusual.
Yeah, that's sort of what I was getting at with my question for Marshall, was that in a leading kind of way, is that my opinion is that don't bother with the package manager until you need it, because you're never going to get it right if you try to front run the actual use. So you get people writing libraries first, and then you write the library manager, the package manager that matches those libraries that has already been written.
Well, that kind of depends on if you can delay it long enough to actually get a representative like field of libraries. Because if you have enough to really require a package manager, but not enough to actually cover all the use cases, and then you scramble to make a package manager for it, I think you could probably end up designing things that are too tailored for that specific case. So,
you're right. Yeah,
we keep discussing the package manager, and we have some ideas about what it should do, and I think it's good that we're discussing it ahead of time. But yeah, I agree. It's you don't want to just implement something to have something.
I know that, like, I don't know, for a language like APL, which has all your quad functions with your quad DT, like we were just talking about, but like your stuff for like CSV handling, different encodings and things, and Uiua has also added a good amount of like encoding type, like JSON and media stuff. A lot of the because things like this are built in, a lot of your reasons that you would have for reaching for a library are eliminated, right? If you have like regex in your language, you don't need a regex library.
Yeah, I think that's very true, and I've even heard our CEO express herself in that kind of way, that it's almost like a whole step shifted over from what mainstream languages do. That we have a core language that can do things that you might need even libraries for. If you're doing things in APL, you don't need to import iter tools and whatever not you're doing in Python and NumPy and whatever. And then we have one step up from there. We even have the system functions included that would be like libraries that are built on top of those general purpose libraries. And we also have those immediately at your fingertips. So there's much less need for libraries. But of course, for some large things, yeah.
Yeah, well, and the big difference there is that when it's provided with the language, you don't have all the versioning, so you can't fix a particular version of the library. Generally, what happens is the language just can't break compatibility with the system functions that it provides. So if you have something where the design is not possible to really nail down, I mean, like, you know,
That's the main philosophy behind languages not adding this stuff, right? That's why, like, you can't generate a random number in standard Rust, for example.
Yeah, because C has like a standard library for this, and it's absolutely terrible. So,
but there are ways around this.
You can always just use a different library. So
yeah,
actually, you know, Dyalog APL had this problem too, where it was using a linear congruential generator as the kind of standard thing, and I mean, that's pretty bad. But so then you have to have another system function to initialize which random number generator you're using and what the seed is, or if it takes the seed from the operating system. And now the default is Mersenne Twister, which I also don't think is that good. So I mean, it might move a lot faster if it was a library that you included.
Yeah, but I mean, I think there's a huge problem there. I don't particularly like the syntax of setting some global state that affects how things are done, but there are other ways around it as well. Sometimes you can have arguments to a system function that chooses a different way of doing things. And I mean, Kai mentioned the experimental things. Dialog.
Yeah, but it's not separating concerns, right? If every time you call a system function, you have to pass in information about which version of the system function you want. Like,
no, not which version.
I wouldn't declare that in a package manifest or whatever you.
No, that's true. But it's not. I wouldn't say which version of it is, but there are. But we can. It's more what functionality you want, and the functionality can include a different way of doing things. And I mean, often it's just a number that you have. You get used to spelling that together. But occasionally we also in a out of arguments, so to say. Or it would be too crazy to try to design around the current specification. So we just add another one. The primitives are like forever. They can't be changed, and you could guess. I guess you could somewhat stop using certain primitives, but certainly they can't go away. And system functions can just descend into oblivion. They don't have to be necessarily removed. They can have documentation that says they're deprecated, use this thing instead. And it's not really that bad to find some other name that's also good for the thing. So for example, APL it's like a standard thing for like almost forever. It has something called quad AT, which is attributes of a name. You give it a name and it tells you something about that name, what it represents. And we've added, so it's quad AT, we've added something called quad ATX, extended attributes. Use that instead. Okay. So a little bit awkward, have another X there. But
yeah, but I mean the process
for
for
dirty stuff anyway, right?
Like you don't go through this big process because, one aspect of a system function is wrong and you want to just tweak it a little. But if you're writing a library, I mean, you might say, all right, version bump from 3.5 to 4.0 changes the way this parameter is specified. And so if you don't want that, you fix version 3.5. If you do want it, you fix your code and move on to 4.0.
We don't do that. In general, things stay very, very stable, like that. The only thing is,
as a result, you have to have a pretty long upfront design process for new system functions. Like
things move very slowly on certain things, and we have it's almost a traditional thing from very early days of APL to use the I-beam symbol for experimental or system services. And we do that as well. Often we'll go many years of using an I-beam with a number for some potential system function until we have enough experience with it to know what the final design should be. And then we may just take the way it was, or we may tweak it slightly. So for example, for many, many years, we had an I-beam for changing to uppercase and lowercase. And then over the course of those years, we learned that, well, there's actually a whole bunch of stuff you might want to take into consideration. Not only there's such a thing as case folding versus case mapping, and even when you do, then there are different standards for it, whether they're length preserving or not length preserving, and there's internationalization, all those things. And then we finally decided on a system function with a proper name. And it takes a parameter and it's intentionally designed such that it wouldn't become more awkward as we extend it to additional things. And there's a process.
I'm going to be a little bit controversial now and take a little bit of an opposing position.
And Conor hates it when it's controversial.
Yeah. No, I think that the reason this is such a difficult choice in Dyalog is because these functions are very much front and center. Like even if it's not a primitive symbol like a plus or a minus, regex quad R is one letter, plus quad, right? Now, if you want to change that, it's a big deal. That's the name. It's quad R. I mean, you have in English you have 26 different letters. You run out very quickly. So giving regex this single letter name is a big thing, and of course you have to consider it.
Actually, use two. Before. It's both R and S.
Oh, and S, yes, absolutely, yeah. R is replace, right?
And yes,
it's not doesn't mean regex; it means replace. Yes.
Yeah.
So if you want to use a different string search language, right? I mean, now regex is as we know quite established, but imagine you wanted to use the Teco language instead, right? Would you change to quad S? You can't.
So there are a couple of things I could say to that. One is, say that would happen. It actually did happen, because very often something you want to do that's somewhat awkward to do, I think, in every array language using just the native the primitives, is just plain text replacement. You have a character vector, and you want to just replace certain text with some other text that's a different length, right? It gets pretty horrible, and regex is overkill. You don't want to have to sit and worry about escape characters and so on when you just want some characters replaced with some other characters. So a few years ago, I said, hey, why don't we add an option? And this is where the flexibility comes in, an option to that the regex system operators, quad R and quad S, should not do a regex. Luckily, they're not named regex. They're just named quad R and quad S, replace and search. So it all works nicely. And that's why we have, well, there's either another argument to give, or we have the special operator, the option operator, or the variant operator that kind of supplies additional parameters in a little bit of a quirky way, but in practice it works fine. And we actually have an option there called regex, which by default is 1. It's true. But you can actually set it to 0, and that switches to, should we say, a different engine, which is just plain text. Don't do regex. And then we have an interesting thing that our regex engine is the PCRE engine. However, PCRE has been abandoned in favor of the very similar but not quite the same PCRE2. They're not compatible with each other.
Why is it called PCRE CRE?
You could change you could like maybe, I don't know, if you have a different philosophy, you could say like, we have backwards compatibility. Obviously Dyalog couldn't do this, but I'm saying a person could say we have backwards compatibility, except for bug fixes and lack of features and or design flaws are bugs.
No, but Dyalog does do that, I think.
We have backwards compatibility except when we break it.
No, but I think
some
I think that's
definition.
true. Right, bug fixes are technically speaking not compatible, right? That's that classic thing. Somebody relies on some crazy error somewhere, and I mean, and that happens. It's not just bug fixes, even extensions that cause things that were not an error before to be an error. Yeah, sorry. So it's something that was an error before to become yeah, that's both ways. Things that were not an error to become an error. Things that were an error to not be an error anymore. I remember my father would occasionally want to stop an APL program with an error somewhere to debug it. And even though there's a IDE way of stopping things, but sometimes it's convenient just to actually type some faulty code. So he would type star power. And then it's easy to search for, and it kind of it attracts attention, and everything stops there. That doesn't work in Dyalog because power is a valid train. So here it just prints that power to the session and continues. So people tend to write now compose, jot. And, but if APL Dyalog was to add these modifier trains, that would stop working, right? What are you supposed to write? Okay, so you can write something that's not an APL glyph, but maybe that will become an APL glyph one day. Who knows?
I mean, the point that
in BQN you have a standard way to throw an error, which is !0. So,
which is convenient, and there's also a way to throw an error in Dyalog, but there's a slight difference between throwing an error and an actual error happening that sometimes makes a difference. I've taken on occasion to write the factorial of a reference to the root namespace. I'm fairly certain that will never become valid, but hey, who knows?
Well, it's still an exclamation mark, so.
Exactly, right, exclamation mark hash. That was
so it would be good in BQN. It would always work in BQN. It's specified.
Yeah.
No, the point that I was wanted to make was that I tend to be more willing to use longer names for things. In my case, the regex search is literally regex : find. It's if I want to introduce a new kind of searching or support regex 2 : find. So longer names.
Right, is a version number in the name?
No. It's literally called regex 2. But yeah, I mean, you can use the package names can change, and the names are long enough that it's okay. If I want to keep some old thing, I can keep it there. It just has a long name. I'm not wasting characters by keeping it. So, but in that is I think a fairly big design difference there, because Dyalog sure loves short names, like your DT, quad DT, for example. Why isn't it called quad datetime?
Nobody even suggested that. I don't know what it is. I would love to know, historically speaking. Almost every like traditional historical system function in APL has 2 letters, and I don't know why. There was no system
I would-
limitations on it.
I would think it's because when you write all your code with every function is like one thing, one character. The moment you have to write out a big long name, you're like, no, I don't like this at all. Why would we make the name so long? We have the power to make it short.
Yeah, if you look at old APL code, especially the papers from the 70s, there are no spaces anywhere. Every single variable name is a single character, and no comments and no new lines. It's just a block of symbols and with single character variable names. And
That's
I think it's
not
tradition.
true.
Okay, fair enough. Some papers, but a lot of them. But I do think there is kind of a tradition in APL from at least that time to write that way. And if you look at, I don't know, code defund source code is kind of like that too. And you know, I've said before that I'm probably kind of unique in the sense that I don't like that at all. If there are not enough spaces, I can't read it. But I do think there's a tradition in the community to avoid extra things that makes it longer. And my guess is that the short system quad names come from that. That's my guess, but I could very well be wrong.
Editing on a typewriter, right, is also hard, and I can see something like that. I think I'd like to correct some of the things you're saying. For example, lack of spaces and things. Some APL systems traditionally stored a token stream for your program, not the actual text you type. So even if you did add spaces between, say, primitives, the system would reproduce your code without spaces, because it would just reform a text representation of the token stream. So when people would publish something in paper, they're developing the program, and eventually they ask the system to print out their code, and then they take that and send it to the publisher, and then they would be without spaces. So that might not be people's preferred style. In fact, until recently, Dyalog always did this, or you had to kind of jump through hoops to make it preserve what you wrote with white space, and even casing and other things, and then how you spell the numbers. And I know there were people who wanted to move from competing APL systems to Dyalog that said that it's a showstopper. Their APL system preserved how they type things, and ours didn't, and they were just gonna come until that got fixed, because they wanted to align columns of similar lines and indicate things with white space and spellings. And so I don't think it's universally true that there's such a style. I do find it excessive to put spaces around mathematical symbols and everywhere, and that I see people doing. I don't see how that adds any readability to things. And names should be long enough that you can understand what's going on, but maybe not longer than that. I know my father did a project for a very large German company, and they had some standards as to how things should be named. They also had some standards as to how long
German,
the lines
right?
in German. Yes, the German names, but they're not just they should be in German, but like what exactly the name should be and be spelled out, and also how long the lines were allowed to be in your program, which ended up being a technical impossibility, because like you couldn't, even if you were just using one primitive per line, so name, assign, name, primitive, name, it couldn't fit on the line according to the specifications. So I think that at some point you reduce readability with that. But whether something has 2 letters or 3 or 4, like I would love to know why the system function APL for copying from a workspace is quad CY. Why? Like, if people were inspired by Unix, it should be like CP, but there's also a system command that, so which is not syntactical APL, that predates the quad CY, and it's called paren copy, with the word copy spelled out. Why did they see the need to press the word copy down to CY? Well, what are you gaining there?
And close paren origin became quad IO.
Yeah, in the index origin, it's interesting, right? But so you might think, oh, there was some kind of technical thing. I know my father talked to me about some very old APL systems where code would run significantly faster if variables had no more than 3 letters in their name, because that was the space there was in the symbol table. And if the name was longer than 3 characters, it would instead have a pointer to the name being stored somewhere outside of the symbol table. So it would do pointer chasing just for name lookups. If in the symbol table, if you had long names. And then there was a new version of that same system that was exactly the opposite, where if things are longer than 3, then it would use the new fancy system, but if everything was shorter than 3, then it would drop down to some old slow way of doing things. So you had to know your system. But parallel to quad CY for copy is quad save, which was always SAVE. So it was not a technical thing, right?
Okay.
I don't know.
I'm out of ideas.
I do think that. Or go ahead, Guy.
I was going to say, I have a question for our implementers panel about implementation, and that is, how are your arrays implemented? Because I think this is an interesting question.
Well, I think we're all using the shape and Ravel format to start with.
Yes, but like, for example, in BQN, not everything is an array, is it? And
No,
when
so
you
is
have
the question,
these-
how are my arrays implemented,
so-
or how are my
So
non-arrays?
it's the array model. What's the array model, is you asking, right?
I'm not asking about the array model. I'm asking
It's
in your implementation language, how are they implemented?
So
I mean,
this is not really
go
for the
ahead.
arrays, but our pointers are implemented as NAND-boxed floats. So many things that aren't, well, or floats are stored unboxed, and other things use pointers, and also characters can be directly NAND-boxed.
Yeah, I mean,
When
the
you-
implementation is very abstract. It's a Java. I mean, on the JVM, it's implemented as a Java reference to a specific class that encompasses a lot of stuff, and it represents an abstract representation of an array. So it has a shape, it has type specialization that you can ask it for. It has a way to retrieve an object at a given position in row major form. If the type specialization indicates that it's doubles, for example, then there is a function called a method on this class that allows you to pull a double out of it. It will raise an error if it's not type specialized, and for other types as well. But other than that, it doesn't have a storage format. There are multiple backend implementations of different storage formats depending on the type specialization, depending on if the array has been fully evaluated yet, because there's lazy evaluation as well. So, for example, if the simplest one just maps it to an underlying JVM array of integers, and then just has a thin layer on top that just presents that to the rest of the platform. But if you do, say, a transpose on it, you create a new object that contains the mapping of coordinates from one to the other. That is the representation of the transposed array. So it doesn't, when you transpose, it doesn't.
You make them abstract then.
They're completely abstract, yeah.
Okay.
Yeah. So for example, the result of taking a iota, like if an array from 0 to 10, say, that array is then doesn't have a store. Those numbers are not stored anywhere. It's just stored in an abstract object that represents a sequence. If you then add the value to it, it will just create a new sequence that has a different offset. So if I take IOTA 1 million and I add 10 to it, I just get a new object back that is IOTA 1 million starting at 10. And things
Does
like
that mean
that.
you have to write different, like, say, add implementations for every, like, abstract array type? Like, if you just add it
No.
if you add one to one that's just represented as an actual array of integers, that's one implementation. Adding it to a range is a different implementation.
Not really. There is all of the scalar functions have an abstract representation. So you have an object that represents an underlying object with some value added to it, or subtracted from it, or multiplied by it, etc., etc. And in its simplest form, yes, you would take an IOTA array, and then you would layer on top this adjustment. But there's an there's also an optimizer that runs. So after the code has been compiled, it looks for patterns. So if it sees the pattern of adding something to an IOTA, something that is a result of IOTA, it will fuse these into a single call to make because there is no way in the language itself to create an offset IOTA array. You have to add in APL, you have to take IOTA and then add something to it. But if after compilation it sees this pattern, the optimizer will replace it by a call to the special version of IOTA array. So there are some optimizations like that. For example, there is internally there is a function that represents an integer dividing two integers and rounding down. Now, that is computed in the optimizer, that is created in the optimizer because you can't call this function directly. But if you were to type round down something something divided by something else, the optimizer will see that and then change that into a call to round to the fused function. So
I want to ask, so if I took something like if I transposed an array, then added one to it, this would be a layering of like a transposition mapping and a
you layer a transposition and then an addition on top of that. Yes.
Now, if I were to calculate that and then reuse that in a few calculations, is there a performance implication for having to go through that mapping multiple times for things? Yes.
In my measurements, the impact, there is rarely a negative impact. There is a performance impact if the operation that you layer on top is slow, but usually it isn't. If it is, yeah, you can force a collapse, which means that you reduce down the layer into an actual materialized array. So you can materialize it with a separate function call. But in general, I've noticed in my tests that it's not really something you have a problem with, except if you have side effects. If you do an each with side effects. So if you do a print each of a big array, and then you use those numbers multiple times, you will print those values multiple times if you don't explicitly collapse. That would be a very controversial, that is another controversial decision that I think a lot of programming language designers would balk at and say, this is terrible. But the point is that the assumption is as long as your code is pure, without side effects, or with safe side effects, then it's fine. If you do side effects in your each, you should know about it, and then you probably should be able to handle it. And there's always an implicit collapse. You materialize the array whenever you assign it to a variable. So in practice, I think I've written a lot of code in CAP, and I think I can only remember a single case where I was bitten by it myself. Now, of course, I'm more aware than what most people would be, but I think that hints that it's actually less of a problem in reality than you might think. But yes, it certainly could have a performance impact. Yes.
Well, the assignment rule wouldn't really carry over to Uiua, so.
Yeah.
Yeah, but there's still the I don't know, having the layers, because I've considered doing that. I've considered having kind of like an abstract array thing. In the end, I didn't know if I wanted to deal with like going through the mapping, because it does enable more things, right? If you have a abstract form.
What I can tell you is that the amount of code you have to write all across the platform to support it, it's a lot. I mean, I think the code base would be maybe half if I didn't do this and just materialized all the time, because there is a lot, and I would say there is probably several hundred test cases that has been created to deal with edge cases that I discovered along the way. So if you want to do it, I would suggest doing it for the obvious ones, like IOTA. There's no reason ever to materialize the output of IOTA. And very often, the first thing you do after you create an array using IOTA is to perform a simple scalar operation on it, like add or subtract. So that optimization saves a lot. And if someone decides to run sum all the numbers from 0 to 1 billion, that is much faster in CAP than it is in Dyalog or any other language. So that's because you never materialize the array.
You can point out NG and K also does this optimization.
But how often do you need to do that? Sum the numbers from 1 to 1 million. I mean,
no. That's why I'm saying that in practice,
that's code that you can rewrite.
Yeah,
it's one of those things that where if I want to pretend that CAP is, what is it, 10 times faster than Dyalog, I show that one only. And then I say, look, it's 10 times faster. In practice, of course, it's I would say it's much more close in reality. But yeah, there are certain things, there are certain specific things that become vastly faster, if you do that. But with the drawback that analyzing the performance or predicting the performance of something can be a bit more tricky, because now you have to think about how these operations layer on top of each other, and am I wasting time? Because obviously, if I transpose a big array, and then I perform computation linearly across all of the numbers, what happens is that each time I read the value, it's transformed into the underlying coordinate, and that is a fairly expensive operation actually. So if you take in BQN a full-on big array, 2-dimensional, you transpose it, and then you, I don't know, just walk over it to search for a value, say. That is much faster in BQN, because in BQN would then allow you to you have this, you get the vector instructions, all of the operations are side by side linearly in memory, while you do the same in CAP and you jump all over the place because of this transformation. So it's not a simple yes, this is faster in all cases, but overall it works well, and I'm kind of happy with how it turned out. But yeah, it's a compromise.
Didn't other APLs have this kind of similar concept? I think they were called APVs, arithmetic progression vectors. I don't know the full history of them, but I thought it was like an optimization in.
Yeah, so every time I brought something like this up at Dyalog, Roger Hui would say, this has been tried before and everybody regretted it. So there are, I don't think the modern implementations have really regretted it, so I'm not sure if that observation holds so well. APL 3000, I think, for the, HP 3000 was the kind of most advanced version of this. So it actually had one of the very early just-in-time compilers, but it also did what it called drag along and beating, which drag along is pretty much the optimization that Elias is talking about, where but specifically for well, I think it's for like shapes and things like that. I can't remember exactly, but so it gathers together like the information for multiple operations as it drags along the expression. And then beating is, I think, the thing that works with arithmetic progressions.
Yeah, so I mean, so so reshape can be a zero cost operation in situations like this. So because then of course if you
Well,
if you have an
it's
array,
just,
Yeah,
how,
all
what are
need
you
to
singling out
focus
as
on
reshape?
though, is
Yeah,
to
reshape is
have
always
shape
free.
and data stored separately. Well, no, it's not free if you have to repeat the data.
No,
Yeah.
no, but I mean,
If
but
it
in reshape
changes
where you're
number of
just changing the dimensions but keeping the number of elements, right? That surely is
Yeah.
is always free.
Yeah, no, I was thinking in the case of reshaping a scalar, and then you reshape that.
Okay,
Because
that's a program. Yeah,
because
sure.
you don't materialize this into an array. You just have
Yeah.
a scalar thing. This has this shape, and then you can just do whatever you want with that shape, even
But
if
you
can reshape it
usually
to a
end
different
up
shape.
if you're creating a giant zero array, say that you want to then populate with some values, you would quickly end up materializing it anyway. As soon as you just add one value to it somewhere, bam, you have to materialize the whole thing.
Yeah,
Unless you do sparse arrays too.
Not in cap, because you don't have you can't modify arrays, and you don't have array modification operations. So you normally wouldn't do that. So you would
What do you
perform some
mean?
scalar
But you have
operation on the
under,
entire
right?
thing.
You have under.
Yeah, you
so,
would
I
use
mean,
under. Yeah.
But but you end up materializing it anyway, right?
Well,
No,
I mean, you could collect those. I mean, it's effectively equivalent to a sparse array. You could collect all those modifications into some sort of structure. And so then what you get out is the representation that this array was initialized with all zeros. And then you wrote this value at that index, and this value at that index, and this value at that index. And once you sort the indices, you have the standard sparse array representation.
Yes. Yeah, that's essentially what cap does. Yeah.
Oh, okay.
Uiua, all the arrays are essentially the same type. It's a generic type, right? It's an array T, where T is usually like one of 5 element types. And I find it's useful because you only have to implement every algorithm once, right? You only have to implement it on one abstract array type. The downside of that is, of course, that when the compiler monomorphizes your algorithm implementation, it generates 5 copies of this thing. So I usually try to factor out as much of the code as possible.
Or what if there are 2 arguments? Do you get 25?
No, I usually do a conversion. So like if it's if it's like find a normal, like a real inside a complex array, it's going to convert the reals to complexes first, right?
What 5 types are those? I was thinking character, integer, float, complex.
The language itself has 4 types, but there's 5 internally, and there's a byte type. So when you read from files, or if you do certain Boolean operations, you generate a byte type, which is to the user transparently the same as a number.
Okay, and then an array itself is not a type in this list. These are the primitive types, huh?
Well, one of them's got to be generic, or no, you don't have mixed type arrays. Never mind.
Yeah, and so it's that, and then the thing that actually exists on the stack, the values that you pass around, it's just called a value, and it's in Rust, it's an enum. In like C, it'd be like a tagged union, right, of just every array f64, array u8, array char, array box, etc.
And your integers your integers are 32-bit, right?
I don't have normal integers. I just have f64s for the moment. So doubles.
Okay. All right. So all maths is following a floating point semantics. Yeah.
I don't know. I do think it'd be nice to have like a nice rational type or arbitrary precision type in the future. I'm not sure about what the best number types for your abstractions, right? Because what do you really want from your math? You want accuracy, but you also want speed, and I don't know. There's a lot of different trade-offs with a lot of different number implementations.
It is. I can tell you that once it becomes rational, because the first thing you want to do is introducing big nums, and then you realize that there's no way you can do division without rationals. So it comes automatically. You need to do the rational, which means that you got rational big nums, and then things become slow once you start to deal with these numbers. And
then I want to take a square root.
Yeah, in square root, in my case, that's one of certain like the trig functions, square roots, and a few others. They always force down to doubles. But what I realized was that the trickiest part to get right, and is quite slow in CAP today, is comparisons, because now most programmers would expect 2 and 2.0 to compare equal, right?
Or a type error, right?
Or a type error. But I considered that, and then I realized, no, most people probably don't want to think about that, and maybe that was a bad choice. Again, controversial, I guess, but so what I ended up doing was that a rational compares equal to a floating point number if that floating point number's representation exactly matches that of the rational. Which means that I need to, in order, whenever you compare a rational with a floating point, you have to convert the floating point to rational, which contains 2 big ints, and then do the comparison there. So whenever, if you do those comparisons, you will see that it is 10 to 20 times slower than just converting it to floating point first. And you were asking about performance problems with the array representation. Yeah, the numeric representation also has edge cases in those situations. In practice, as long as your arrays are not too big, it's not a huge deal. But if they are big, like you're dealing with image data, for example, you probably want to reduce it down force it to either integers or floating point before doing comparisons and things. So it's tricky. That part is really tricky, especially when computing the hash code for a number, because now you want the hash code for a floating point number to be exactly the same. If the floating point number has an exact rational representation, then those have to have the same hash code. It was terrible. The actual commit I did to implement all this stuff was one of the largest because it hit everything across the board. Every single part of the code that dealt with comparisons had to be adjusted to deal with this. It works. Well, at least it passes all my tests, but I don't know. Yeah, it was tricky. And I couldn't steal Lisp semantics either, because Lisp has 4 comparison functions to deal with this. Yeah.
On the other side of going to smaller types, I did recently write a page on what in BQN's implementation notes on choosing representation types if your only semantic type is a float. I mean, I guess I could probably add sections on what to do with on how you might add additional types, although that's kind of more of a design question. And yeah, so I went over the benefits of what do you get for introducing 32-bit ints as a subset of floats and 16-bit ints and byte booleans or bit booleans. And so I've got a few different kind of simple refinements you could do there. The first thing I would do if I wanted to optimize Uiua is probably add 32-bit ints, although maybe I'd consider 16-bit ints instead, because then you don't even have to implement a hash table or anything for speed. If you want 32-bit searches to go fast, you need a dedicated hash table that's specifically designed for that size, really. And 16-bit ints, you can just use a lookup table instead, because 16 bits gives you 64 kilobytes for a table, which is not that big, and you can sparse initialize it so you don't have to actually initialize the full table, and it works for small sizes even.
My main concern about if you're transparently trying to present, there's only one number type, right? But you have some inner implementation smaller types, which I do have. I have a U8 type, right, for bytes. But the moment you add 2 of those, say, integer arrays together, does that mean you have to check the values of all of them before you add to see if they'll overflow?
Yeah, you do. But addition with an overflow check on a smaller type. So you have to be able to write it in a way that the language is going to support well. So getting it we vectorize that explicitly. But
do you do all the checks first and then add, or do you check and add each number individually?
Well, we do everything on vectors. So,
Okay.
like if you have the implementation done well, it's actually the overhead's pretty small. 10% is what I gave for the kind of average cost versus not checking.
Oh, the check is only 10% of the cost, you're saying?
Yeah, because in the full operation, you have to, like, if you're not doing any sort of lazy stuff or compiler fusion or anything, you have to read in a vector from both arguments and then add them together and then write. And most of that time is spent in the memory operations. So really, if you add a check, and like on x86, usually what you're doing is doing the regular addition and then the saturating addition as well, and comparing whether those are equal. Depending on, like, for some types that's not supported. So x86 is really a mess.
When you do vector adds, you add to like, was it 4 numbers each time together, right?
Well, it depends on the size. I mean, it's for SSE, it's 16 bits of vectors. For AVX and AVX2, it's 16 bytes of vectors, or 32 bytes of vectors. So
can you do overflow check on all of the results in one go and say, did any of these overflow? Yeah. Okay.
Yeah, so you do that, and then the way to, like, once you've decided that there was an overflow, you can choose how to handle that. You might just, give up and restart the whole operation. Since overflow is doesn't happen that often. I mean, if the thing overflows once, generally, then you're moved over to the next type up, and it's going to take a while for it to overflow again. So you could restart, or you could try to reuse your work up to that point. But
that
yes,
was
so the
issue
operation plus the overflow checking is still much faster if it's properly implemented than the same operation on a larger type.
And when you say properly implemented, do you mean like properly vectorized and optimized? And...
Yeah, well, so probably the thing without the overflow check is going to auto vectorize. So you really want to write it in some way that's going to get it to vectorize. I don't know if there's a consistent way to do that without actually writing the vector code. So that may be a problem.
Yeah, I still rely on the auto vectorization just because it's easy. But
well, you don't have to worry about
even if my actual array types are complex, by the time that you're adding all the numbers together, it's just 2 buffers of data, right?
So that's the Rust compiles with LLVM, right?
Yeah.
So you're relying on the LLVM auto vectorization stuff. Does it work well?
From my experience, yeah.
I mean, it really depends on what your standards are, right?
For the things that I don't know, for the things that are easier for it to vectorize, like addition, I mean, your basic math, right? Yeah, I've benchmarked it against like the equivalent C or Rust code, and it's the only speed difference is like the interpreter overhead of actually starting the program. But otherwise it matches it. So then I check the instructions, and there's the vectorized instructions in there. So
yeah, so generally what I find is if you're doing over some number of arrays and just do the same operation on each element, that I mean, maybe if there's some weird type conversions, it won't vectorize, but it's pretty much always going to vectorize. And if the code isn't weird, then it's going to give you basically optimal code. Then if you have some like shuffling around between indices or something, it really depends. Auto vectorizers won't do scans, which really doesn't make sense to me because it's like
really
a very basic thing.
Well, no, I know they don't do like reductions either, right?
No, they'll do reductions. So like if you want the minimum element of an,
I've not been able to get a reduction to vectorize.
Maybe in floats you can have problems with like, because it has to account for nans. So yeah, because
that's always get me.
Because yeah, the x86 float min instructions are actually not commutative. Which, so I guess the way they designed it was to match the ternary expression a less than b question mark a colon b for min. So it's like if either number is a nan, you get the one on the left or something like that.
Yeah, it is.
So it's really weird. And that means that it does not have any nice algebraic properties.
Which also
and
means
so
it breaks IEEE specified behavior. So if you want correct behavior, you have to
do
add
they
extra text.
specify
Huh?
min and max?
Oh, I break IEEE anyway on purpose.
Yeah,
No, because
I mean, NANDs are a really hard case.
Yeah, any operation with NaN should always be NaN, right? So you should never get, if you do a comparison with
Yeah,
NaN,
but I
you
don't
should
know
get
whether min and
number.
max are IEEE specified operations. That may be the problem.
Oh, minimum. Yeah, well, maybe. You're probably right.
This is APL hasn't had enough influence because min and max should be considered basic arithmetic with everything else. They show up in so many computations.
Yeah.
They're equally simple as the absolute value. I mean, that's not a smooth function either, or you might say complex analytic. And like they are just a basic thing, and yet we have all this, tons of programming languages just don't handle them right.
MAX parentheses. Yeah.
Yeah,
I can almost guarantee you that there is I don't know which one was the first processor implementing IEEE or something, that type of, the early floating point processors or coprocessors probably did not have that. And that, I have a feeling that influenced IEEE, and then IEEE influenced the CPU design or language design moving forward. So we're stuck in a vicious circle.
Still doesn't have min and max instructions in general purpose registers, so you can't take the min and max of an int simply. You have to
really
compare them and then do a cmove instruction.
Don't you have a conditional exchange? Swap.
Yeah, but it's like that's not how it should be implemented. That's like implementing it in C with the ternary operator. It's a more basic concept than that, so you shouldn't represent it as a conditional.
That sequence might be optimized later inside the CPU itself in the decoder.
Well, it would be if there was an instruction for it. In floats, it's
no, but you have the sequence, right? That should be identifiable by the decoders.
It's not okay.
It's not very fast. Like, it's faster to do max and min in floats sometimes. Like to convert all your data to floats and then do the max and min there instead of trying to do max and min. Well, if you're going to do it in the scalar registers, like if you're not going to vectorize it. If you're vectorizing, then you have integer max and min instructions. But if you're doing stuff in general purpose registers, then you don't.
If I didn't have enough reason to be upset about the x86.
Yeah.
It reminds me of Go before they got parametric polymorphism in 1.18. That's what their float function was. You would always have to cast to floats. And then, so if you had two integers, you would have to manually cast each one to a float. Then you'd get back a float from your min and max functions, and then you'd have to cast that back. I think I actually haven't checked since Go 1.18, which was a year or two ago now. But I imagine that they now have, because that was my biggest pet peeve, like of Go. But hearing you say this, maybe it was intentional at a certain level. Probably not, but like there's a chance that.
I mean, well, obviously they considered that decision. I mean, there's no way they didn't consider what happens if you want to take the max of two integers. But yeah, I mean, possibly they just decided that max wasn't an important enough function or something like that. I mean, if I were doing that, I would say, like, I don't care about the other floating point functions, but we need to have max and min on integers be a single function. No matter what sort of, like, it should work like plus, basically.
Yeah, I mean, it's totally a separate topic, but it's a pet peeve of mine that you have like the naming of the binary operation versus the name of the reduction. So if you're implementing some library, you have, and the thing is you can't not provide sum, right? Like sum is the reduction name of the plus reduction, and almost all libraries have like prod or product for the multiplication. But then there's not even names because they're not common enough for division and subtraction. But then you get to min and max, and because those didn't have symbols, every library does something different. Haskell calls their binary functions min and max, and then the reductions minimum and maximum. And there's just like you could go through the list of languages and what they do. You know, technically, I think Python, it's just duck typing, and so it'll figure out, like, if you pass it 2 integers, it works. If you pass it a list of numbers, it works. If you pass it a generator expression, it works. But yeah, it is. I think you said, Marshall, APL hasn't had a big enough influence. It is very sad that there is not like there is an established in APL and BQN and all the array languages, min and max glyph, but it's not on your keyboard. I mean, and for that matter, neither is the multiplication sign. So I don't know. It's I don't know.
Yeah, and I mean, so there could be a standard digraph for max and min, like same with less than or equal to. Pretty much all mainstream languages write that as less than followed by equal to. So we could have something, less than plus or less than exclamation mark or whatever for max and min, but nobody felt
but
that.
not in mathematics, surely. Only in programming languages.
Oh yeah. But like so I mean, you come up with some symbol in mathematics or use the one that Iverson suggested.
No, that doesn't really work, right?
Yeah, I guess if you write A min B, well, maybe.
How do you determine if you have
symbols, ceiling and floor? But
yeah, if you don't make different sizes of them, how do you determine if it says like A up style, B up style, C, and then like the reversed up style that you would use? So is it
you don't know which one is
which one is paired up with the
ceiling.
Yeah, so that doesn't quite, but I mean,
but you
it
can
could
of
be
course
some other symbol
at operator size is one option.
Or
you
it could
pretty easily come up with a similar symbol too. So
it could be, for example, be a very long like T-like symbol, like a long down tech, up tech thing that just has the bar on both sides that doesn't resemble anything else. And yeah, it's just silly that these don't exist in other languages. But then again, it's a good thing we have languages where they do exist.
Yeah, it's just frustrating that we then have to implement these languages.
I was sitting here listening to you discussing all these implementation details, and I was like, wow, it must be so hard to be this low-level implementer for these languages. I'm a different class than
this is why
than you three. Yeah, okay,
So.
but you have to implement that. When I need a new primitive, like the before reverse compose operator like that, I write an APL model, I write some tests for it, some sample usages, I argue my case, and I hand it over to somebody to rewrite it in C, and then I don't worry about it again.
Well, yeah, but Singeli doesn't even have any built-in operators. They're all defined in the user space. So their standard includes that you can have to get C-like operators, or you can just define whatever operator you want yourself. So I've done that all the time. Like, so one time I was defining code for sorting networks, and every sorting network is defined as a list of, pairs of indices that you would compare and swap. Or you might say, put the min on the left and the max on the right. And so I defined a function, an operator that just takes 2 numbers and returns the tuple of those numbers. And then so my list, I can write, 1 less than greater than 2, comma, 3 less than greater than 4, and so on. Like I can get a completely custom operator wherever I want, just temporarily.
We're talking about like things that we miss in other languages when we're doing this. When we come from array languages and we use other ones, the one I feel the most, I think, is under. I have so much Rust code. Not so much. There's so many times that I set a variable, do something, and then set it back to its old value, or push something onto some stack variable I have, do some operation, and then pop it off. And I get it, right? Like there's not the way that non-array languages work. It's not really a thing that generalizes very well, but it's such a common thing that you want all the time.
Yeah,
Yeah.
I mean, how many times would you have to write mute and ampersand to use under in Rust? That would be rough.
I don't want to get into having to write ampersand and asterisks everywhere in Rust. It's that's probably my biggest pain point, honestly.
I think, I mean, on the chat we've had on multiple occasions discussed the whether or not under should be pure in terms of computational versus structural, or if it should be a little bit YOLO, like Gap, and I think Uiua does something similar. In other words, doing whatever seems reasonable, and instead of having a very thoroughly mathematically correct definition. And Dyalog has some plans, right, to get this as well, but it's not clear to me how far along that is. I don't know if you even decided on which semantics to use.
Well, we've been discussing whether we want to have two separate unders, and which I think we probably would, because one is, well, there's some fundamental differences, and what you call the mathematical computational under often want to generalize, so it applies to either one argument or both arguments, pre-processing both of them if there are two, and then undoing that pre-processing as final step. The one that's selective or structural under, usually you don't want to do that. You want to only perform that selection on one argument, and either you want a separate argument unmodified as a left argument to the modification function, or you might want the left argument possibly to be a parameter in the selection. But either way, you generally don't want the same thing to happen on both arguments, and you have to choose which one is the one being modified and which one is kind of the fill value anyway. So one of them is symmetric in nature, and one is asymmetric in nature, and it doesn't seem quite right to have one thing. There are the issues that certain things are invertible in two different ways, structurally, computationally, give two different results. Both of them are logical correct, and being that the traditional way of writing under yourself, which is applying inverse function to the result of modification function to the under result of the preprocessing function, already gives one of those two results, and the other one is often what you would want. Kind of have to separate it this way. So there's still some things to be discussed.
I mean, I disagree that the dyadic structural under, where you're modifying two arguments, is really that rare. So one example that you might use is for what's called, it's not mesh, it's mask in Iverson notation. If you have like a Boolean list and two other vectors, and you want to choose the first vector where you have 0 and the second one where you have 1, you can write that as a left tack under mask jot compress and then the right argument. So and that generalizes to any sort of structural selection. So you can take parts from one thing and put them in the other thing when they have the same shape. And I think there are a fair number of cases like that where you have, two arrays that are shaped the same, and you want to use one as kind of guidance on how to modify the other. So, I mean, it's less common, I guess, than having a left argument to a structural function that's just unrelated to, that's like that you want to bind in as the structural function. But it's also pretty annoying to do if you if you want to do it, you have to kind of write a custom operator or something. So that functionality is just not, you would be cutting out the functionality entirely, as opposed to making the left argument thing just less convenient to write. So
Yeah,
I don't
but
know
really,
where I stand on that.
really there's a triplet of these, right? We now have compositional operators to pre-process right or left or both arguments. And here we're adding another dimension, whether we should also undo the pre-processing at the end. So really, there would also be 3 of those.
No, I think it's just which one you're processing at the beginning.
That's the same
But then,
thing.
of course, if you have 3 arguments that you all want to process, then it's then that's a whole different deal.
I mean, I simply see it as you have a value. You want to do something with the value, compute something, and return it back. That value just happens to be the right argument, right? I don't see why you would consider the second argument as part of the pre-processing. It doesn't really, unless I completely misunderstood your argument, I don't see how that would be convenient or logical. Since I am so confused, I must have misunderstood.
Well, if you have a second argument that has the same format, which I don't think is that that unusual. Like, I mean, if you have a database where you're storing the columns as vectors, then maybe you want to work on 2 rows, and you've got like you want to add parts of one row to another row. That's kind of artificial, but maybe there's another function you want to apply in that way. So you'd have your selection function filters down to which rows you want, and then you apply that to the 2 columns.
I think it becomes
yes, but only the columns are affected, no? So it's only those columns that needs to be transformed.
And one is the right argument,
which would make these columns that you want to change the right argument, because that's the one you want to manipulate.
Well, no, but then the format of your so you're saying you gather them all together in the structure at the beginning, and then you're so then your function is the structural manipulation each. I mean, I guess it works. It's just that the result that you get back out also includes the column that you didn't want to modify. So actually,
well,
no, it's
I would pass that. So let's say, for example, you want to do the absolute most simplest under operation you can imagine. That is, you add 1 under the multiplication of 10, right? That is effectively adding 10, right? So 10 is a number you want to 1. Sorry.
Wait, no, what? That's adding a 10th. You mean?
Yeah.
Yes.
But so
yes, correct. Yes.
What I have with the
absolute
column
simplest.
Okay, not even the simplest case was simple enough. So,
but that's
my point is, if you start with 100, right, that is the number you want to manipulate. The function you apply multiplies by 10, makes it 1,000. Then you perform the operation adding 1. That's the data you want to work with. That might be the left argument, and then you undo that operation. But in any case, the number 1, the number that I added, is not part of the transformation. The thing that is transformed is the number I start with. That is the same number I get back after modification.
Well, now this is actually the opposite thing of what I think Adam was saying was useful for structural unders, which is that you want to take out the 10 and make that the left argument.
That's one possibility. It doesn't have to be, but for the structural under, I would say more often than not, either I only have 1 argument, or I don't want the same transformation done on the left argument to my function. So let's say the simplest is not a very simple example is, let's say I want to add 1 under 3 take, meaning I want to add 1 to the first 3 elements of my array, right? So I might think I could write 1 plus under 3 take, by whatever way you spell 3 take. However, if 3 take is apply to both arguments, then at least with the way Dyalog APL works, 3 take on 1 is 1 0 0. So I get 1 0 0 added to the first 3 elements of my array, which only adds 1 to the first element, not all 3.
Right, and that would not make
yeah.
any sense. Which is why you
Well,
don't
it
want
makes
that.
perfect sense. It makes perfect sense. It did exactly that. It's the same thing as the over or whatever name we want to call it. Pre-process both arguments using some function, and then apply the left operand, whatever the main action, and then you undo the first one. That's the edit step, right? So we took the first 3 elements of both of them. I got 1 0 0 and whatever first 3 elements, and then we did the operation plus, and then we stick them back where they came from. Undo the 3 take.
I mean,
It makes perfect sense. It's just not what I want.
Uiua disambiguates this with like additional modifiers, right? So if you just do like under times 10, and then some binary operation is the non-transforming part, right? If in something like BQN, it'd be like times 10 or like f under times 10, right? So if I do in Uiua under times 10, that's going to apply the times 10 to the first argument. But then if I under dip times 10, that's going to apply it to the second value. Or I could do under both times 10, and it's going to multiply both values by times 10. And then if I said like under times 10 plus, it's going to multiply both of them by.
When you're inverting both, wouldn't that normally
if the signature of the second function is like, say, it takes in 2 values, if it's a dyadic second function, right? If I do under both times 10 plus, it's going to multiply both by 10, add them together, and then divide the result by 10. So it removes the both at the end. It just does
so
it
is that
on
done
one
with
argument.
special handling on both? I mean, like if you write your own function that happens to be 2 to 2, it can't know to convert that into a 1 to 1 function, right?
No, so if you're instead of plus, you did like I don't know, something that produces 2 arguments. So it takes 2 arguments and produces 2 outputs. It would undo both on both of those, right? It's not special handling on both. It's special handling on like the instructions that both produces. But basically, yes. So if you wrote like some equivalent thing yourself, it would do it the same way. Actually,
I don't see how that can be
maybe
possible.
No, it wouldn't. You're right.
So
like,
yeah,
the
that's
that you can select which arguments you want your transformation to apply to, basically. And regrettably, you can't do the opposite, right? You can't do under times 10, then a function that takes in one thing and produces 2 values, and then reverse the transformation on both of those. At least in most cases. There's some special cases, but
yeah. I mean, so I disagree that that if you have a left argument, it's usually the case that you don't want it transformed. I mean, I would say that's about it's about as common that it would be in the same format as the argument, or versus the same format as the selected argument. Although, I mean, I don't know how I'd consider the case with the scalar, because that's I mean, that's kind of its own thing.
Of course, there's a way to around it, right? If I just bind that 1 to the plus, so it's
Yeah.
in
Well,
APL would be one jut plus, done. But I think it's not so straightforward. I think
it's tricky.
Yeah, and well, language design is hard, and I think I kind of have to be able to play with it to see what the economics of this are, and it's hard to imagine a way to a proper design for this. Just like people can dismiss compositional operators by like, it doesn't do anything. That doesn't do anything useful. Why would you want to use that? Because they don't see the patterns in the code where those are such perfect fits that makes everything so nice. Right? The same thing here. I would suspect that I don't see the patterns that Marshall is speaking about, where I want to transform both arguments and then merge them together somehow and undo the transformation, because I don't have the experience with it. I can almost say I don't trust myself to design this, and if I don't trust myself to design it, then it probably won't happen anytime soon. because then who exactly should be designing it?
I've come to realize the one I use under quite a bit, but the one case where I do use it the most is to add or remove rows or columns. So I do a drop the last column under the take of 3, right? That drops the third column. And that is incredibly succinct with the under, and I don't, I don't know of a great way to do it in Dyalog other than using bracket indexing and using IOTA in various ways to get the subset of the columns.
I think I'd probably write 2 different takes and concatenate them together.
I think I would write a replication vector instead.
Yeah, that would also work.
So if you wanted to remove, say, rows, columns 3 to 6 in a 2-dimensional array, how would you write it in Dyalog? Because I've needed to do that in Dyalog. I ended up doing the concatenation like you said, but surely, I mean, it's so beautiful the way you do it with under.
Yeah, I mean,
but
if
how do
I
you
know
remove
how
multiple
long it
columns
is.
under?
Sorry?
How do you remove multiple columns? You said columns 3, 2, and 6, right?
No, the 3, 2,
Well,
6.
3,
3,
6,
4,
yeah.
5, 6.
Oh,
It's a
between
range.
3 and 6. All right.
Yeah. So 3. So you want to. So it would be 4. I mean, you need to transport as well, right? So a 4 drop under the 3 drop of the transpose is how you write it, I guess.
Well, in CAP, I would use the fact that you can specify null as the number to get all of the rows. If you want to take just one column, you can do null one null one take.
Okay, but okay, fine. So we can do each. I don't know why you would need null here. You can just do 0 and 0, 3.
No, then you take
drop.
0. Then you take 0 rows, right?
No,
You
drop.
want to take all the rows.
Can't you just
and one
do a
column.
3 tick under 6 tick?
No,
Yeah,
but it has to be on
if
the
I have
columns.
under, but if I don't have under, how would you write it as nicely as possible?
Well, you want to
I would
extract those
write-
columns, or you want to remove the columns?
I want to drop them. I want to drop.
Drop them. Yeah. So it's
Yeah,
a 4.
sorry.
It's a 4. In principle, a 4 drop under a 3 drop, but you have to do it on the columns. But you can do a 0 in front. That's the traditional way of doing an APL. I don't need any nulls. If you do a 0, 3 drop on a matrix, that's dropping 0 rows and 3 columns. So you remove the first 3 columns. So you could write 0, 3 drop under 0. What is it called?
But then you need to
A
do
0,
a
0, 4 drop under 0, 3 drop.
But you need to do a take to put back the thing.
No.
Yeah. Well, so the way I would write it is
Under
just
handles it.
3 take, comma, I guess it's 7 drop.
Yeah.
Yeah.
And
Yeah,
I do
that's
that function
fine.
on each row.
Me
Or,
writing
And if
I
you
one.
want to
guess
do it on column, you transpose before and after.
No, I just write the whole thing. This 3 take, comma, 7 drop function. I'd write that cells or rank 1 or whatever. And yeah, if I know that's not going to optimize, I mean, I might distribute the cells to all the different functions myself, but that's the basic idea.
But if you had specific columns you wanted to remove, then I would just have an all one vector and then negate at specific indices and use that as a replication vector to replicate along that axis.
I have a thing where you use that.
That's the answer I was looking for, I think, because that is actually much more clear than the mucking around with stitching the arrays back together. But which I ended up, when I had to do it in Dyalog, I ended up doing it like what Marshall explained. But yeah, you're right. The replication vector is, and then you can use the same trick to duplicate also.
But you could do that as well. But another traditional way of doing it would just be using square bracket indexing, so with an empty first segment. The second segment is iota without the specific indices you want to remove if they are scattered. And
Yeah, well,
it's not-
you could have iota
It's not too
3
bad.
and comma 7 drop iota.
you can do that as well.
Yeah.
Yeah, but I'm
will
saying
say
if they're scattered, you would do it like this with or without.
I will
And
say that the implementation of under is probably one of the most I don't know, one of the bigger sources of weird bugs in the Uiua interpreter. Well, it's in the compiler, right? But there's so many weird cases that you can run into, especially when you do what I discussed, which is like under this function or under both this function, or there's a lot of weird stuff.
Yeah, I had a bunch of issues. Not too bad, but the edge cases are a bit obscure that you run into. Also, I don't know. There is a subset of tacit expressions that you can apply under on. Reversible tacit expression, like a regular 2-chain, or the well, there are only some that works. That where you don't if you have a chain of 2 functions that support under, then the tacit expression that joins them together also works, but you can never do it on a fork, for example.
Well, so this is because you're using the ad hoc version of under where you specify how each individual function works. So the mechanism I use in BQN, which I actually got from Dyalog selective assignment, so it already sort of has this implemented. There are some implementation concerns, which is one issue with the way Dyalog's done it. But the idea is that you have your array, and whenever a structural function is called on it, it expands it into a conceptual list of indices, and then it works on that. And if you ever pass these indices into a non-structural function, then you get an error because it needs to be manipulated structurally.
You're right about the
length,
fork,
it'll just
though.
tell you the length because that's known. And so then at the end of that, you get a representation of where all the values came from in the argument. And you can use that to put all the values back in. So,
that explains a lot in the behavior of under in BQN. And all of them are implemented in this way?
yeah, so there are some special cases that are done in CBQN that are done in the having specific function implementations just because it's faster, but that's always a subset of what's done with the general method.
Could you do an under in BQN that requires like solving an algebraic expression? Like if I have a fork and one time like
well, see, that would be a computation.
One time squares. No, but I mean, like for example, if my fork is times 2 plus power 2, right? This is essentially the equation x squared plus 2x. And could it handle that? Because that's like an algebraic thing.
No, I mean
the
equation. So that goes to inverse, and BQN's inverse just it does this thing where it has to know about specific functions and deal with all of that, and so it doesn't know any algebra, so it can't do polynomials or anything. Dyalog has a polynomial solver in its inverse.
I always thought it would be a cool thing to add.
Yeah, I was thinking about doing something like
have some polynomial solvers there. Although, I mean, then you eventually get in the question of, well, the big issue is that it gives you just one root back, and you have no way of controlling which root it is. So it's not actually very useful as a polynomial solver. I mean, you still got to build your thing out of it that takes this root and then removes it from the polynomial and then calls it again to get more roots. And then that you can't necessarily control the precision of that. So, you know, maybe you've lost precision when you reduce the polynomial. And so you probably still have to go back and polish up the roots that it gives you for the original polynomial. So that's kind of a mess if you want to build anything serious on top of it. But yeah, Dyalog
it's one
has
of those
polynomial
cute
solver.
things that you can do that is cool but useful, not really. But it's a great demo to show. Oh, look, I can invert this obscure thing.
Well, this is the perfect. I've actually been planning on having this be the out, and it's come up naturally, organically, because this has gone a lot longer. But I'm super happy that everyone's been able to, especially Elias. I know it's past midnight for you local time now. But one
I'm a night person. It's fine.
Yeah, luckily for us. One of the coolest things, and this is will kind of be like the final thing. So start thinking of something similar if it exists in your language, and maybe that'll be like the little Easter eggs that we're telling the listeners / watchers about. And unfortunately, Marshall, you're gonna have to come up with a second one because the example I'm using is in BQN. Is an inverse. I was solving a problem the other day, and I've known about inverse where or replicate. What's it officially called in BQN? Is it called where or replicate? Or indices?
Indices.
Sorry.
It's indices.
Replicate is the dyadic one.
Replicate is dyadic. Indices is monadic.
Yeah, so I think it's called where in APL, indices in BQN.
And I guess the indices undo if you want the inverse to be technical.
Okay, indices undo, aka inverse. And I've known that if you have, and to explain for folks that are potentially listening or watching that aren't familiar with where, you're given, when you're using the non-inverted or non-undone where, you're given a list of Boolean zeros and ones, and it returns to you all of the values that correspond to a one, like in a corresponding.
All the indices.
Iota sequence. Yeah, the indices. So if you
It
have,
doesn't have to be Boolean.
it doesn't have to be
It can
Boolean.
be-
I'm starting off, because I think it makes the most sense initially. But if you start off with like 1 0 1 0 1, because BQN is 0 indexed, if you take the indices of that, you get back 0, 2, and 4. But it doesn't need to be just Booleans, because that actually what?
Because it's, if you had like 0 1 2, it would give you back 0 0s 1 1 and 2 2s, right?
Right. Which is why.
Which is why your example from your video or your presentation that you uploaded a couple of days ago is actually 2 characters in APL. It's where iota. If you want 0 0s 1 1 2 2, it's just where iota 6, and that gives you 1
Oh,
2
yeah,
2
you
3
were
3 4 4
self-replicating,
4
huh?
5
I
5
watched
5
that.
6 6 6 6.
Okay, wait. So the video that you're referring to, Elias, is my recently given Lambda World talk, and I showed the equivalent of a closure expression that was given in the keynote at that conference, which was replicate with the self, aka the W combinator, followed by range. You're saying is it just in cap, or you're saying in APL in general this is only 2?
APL also. I can since
And
we
BQN,
haven't shared any screens at all this time. I will do it just to demonstrate here what I mean, right? So you would do. Let's make it larger so we can see. Where iota, and I think you use number 6, right? And it's the same in APL. So the solution is actually only 2 characters long. I thought that to myself when I saw your presentation.
And it's also not casting shade on BQN, but the symmetry of this. Oh my God, what a missed opportunity! That is gorgeous. Okay, well now that you have this up, I'm actually not sure if Cap does this, but so what I was getting towards, this is amazing way to end this podcast, was that you can use inverse or indices undo, inverse where, however you want to spell it, to get the kind of histogram, if you will, because one of the tricks that BQN does is it will sort if you have unsorted data. So I was actually building this up and had put a manual sort in there, and then I remembered from an ArrayCast episode that you had actually mentioned this, Marshall, that like, we
eventually made this extension.
Yeah, that, and then like, it's kind of
And it doesn't do an explicit sort. It's an implicit sort, and actually it's the other way around. That sort is implemented using this method on integers.
Oh,
Yeah.
interesting.
So one demo, when I want to show someone how to do simple calculations in APL, I usually say, I usually do something like this, right? I say, okay, I want to take 100 die rolls of of 6 dice. So and then a question mark. This gives us, so each row represents a die roll of 6 dice, and and then I want to add +1, of course. So you sum it across, and you get these numbers. Now these are your die rolls. In CAP, I have to sort. In BQN, you don't have to, but I sort it first, and then I run the inverse of where. This gives us this number, and then of course you can plot it like that. Now, if we increase this to say 10,000, you get a nice distribution like this. I think this is the kind of thing with inverse where that you were getting at, correct?
Yeah, it's because it. So as you mentioned, CAP doesn't do the implicit sort, but
Exactly.
this
So
was,
in BQN, you wouldn't need this sort here, no.
exactly. But so this kind of thing was, and this is amazing that along the way we got to see the iota underbar iota solution in CAP, which also works in Dyalog APL. The question is, do I have to go and I was kind of done giving that talk because I've given it a couple times, but now maybe I need to go re-give it, or maybe I'll just make a YouTube video or something showing that. But so the question is are there other, do you have an example of a similar, I don't want to call it a trick, but it is like a very, very beautiful expression that like folks might not know about. Like I'm guessing probably in Uiua there's a couple under things or inverse things that I'm not aware of, but like that are very cool. Like now that I know, and that's the thing is, if you want a histogram, sometimes the zeros there, you won't want them. But like in other cases where like you might be reaching for whenever I'm in Python and I need this kind of frequency count, I think actually Clojure has a function called frequencies. Smalltalk calls it frequencies. In Rust, in the iter tools extension to the iter library, there's one and they call it counts. And in Python, they have the counter collection, which will give you a dictionary of values and keys where the keys are the counts. It's a super useful thing. And anyways, like sometimes, so instead of reaching for group, you can reach for this where inverse, or I should say indices undo in BQN. So I know it's kind of, I'm springing this on you. I didn't send you this while we were organizing. Do you each have, like, what's the closest thing? Yeah, Marshall, if you can, come up with another one for BQN. I see Kai nodding his head, so maybe we'll go to Kai, and then whoever wants to after that can come up with the next one. Because I think these things, they don't get highlighted enough. Like, we know about them, or like I don't even know about some of them, and then you see it and you're like, holy smokes. Like if you can show someone one thing and blow their mind, yeah, what would it be? Or maybe that's a different question, so table that question.
Yeah.
But,
this is different. This is using the primitives in a it almost like this is the proper usage of the word idiom, where the primitives don't at face value tell you what it is you're getting. I mean, they do if you think about what it says, but it's not so obvious at first sight. But it's something you can learn this phrase. Yeah, it can do this clever thing, like the where inverse to make a histogram. I have one, I think.
okay, we'll go
Follows
Adam,
this criterion,
and then we'll just go whoever wants to after that.
It's not my own. I got it from Dan Barone, who was my mentor at Dialog when I started, which is the decode selfie, if you want, or that on a Boolean vector counts the number
You want
of
to share your
train.
screen?
Sure, I guess I can do that. 1 second.
We haven't seen enough APL on the screen today. It's I'm starving.
So how does this work? I just find out exactly how to share. To make sure I share the right
share
thing.
button at the bottom there, a little
Yeah, no,
square
yeah, but I have to figure out which window to
window?
share. That's the problem. 1 second, I will. I'll make sure to and which screen. I have multiple screens as well. So give me a second. So I can share screen 1 or I can share screen 2, but I don't know which one is screen 1 and which one is screen 2. So
You can share an individual window. That's probably better. Also, better for privacy, I guess.
Yeah, exactly. Oh, okay. Now I have it. I got it. This one. Yes. Oh, it gives me a preview of it. Good. So let's say we have a Boolean vector like this, and I want to count the number of trailing ones. So in this case, it would be 3. And a straightforward approach to this would be to start by reversing it like this, and then we can do an AND scan on it, and then
You
does
need
a
under.
eliminate.
Yeah.
Well, no, you don't need under.
No, we don't. No, because we don't
Not
need
really.
to reverse it again. We don't need an under here, and then we do the sum, right? But then Bernet came.
Before you move on, can I ask a question about this? Because
Yes.
the way I would do it is I would get the index of the first 0. Would that be faster? Because you wouldn't need to scan the entire array. Imagine if the array is really long.
I guess it would be in principle, except the interpreter recognizes this phrase and does it fast. So it doesn't actually do what it says in the tin.
right.
However, Dan Bernet came up with this one instead.
Huh?
Because so let's unpack this. So there's a selfie here. Let's eliminate that one first. This is mixed base evaluation. So this is saying that this digit are the ones, and this is the 1 times ones, and this is the 1 times 1 times ones, and this is the 0 times ones times 1 times ones, and this is the 0 times 0 times 1 times 1 times ones, and this is the 1 times 0 times 0 times 1 times 1 times ones. But of course, as soon as you hit a 0 in this progressive multiplication from the right, then any digit has a weight of 0, and therefore all these numbers are effectively ignored in the sum. And since these were all in 1 or 1 times 1 or 1 times 1, so any power of 1 is 1, then the sum of the whole thing is the number of trailing ones. And therefore you can compute it, the number of trailing ones like that, and you don't have to reverse or rely on the interpreter doing something clever or implement it yourself using a lookup.
Have you used this before?
I use this every once in a while. And it used to be fairly slow because the interpreter would go through all the motions of mixed base evaluation to do this. But since Dan Bernet was writing a lot of APL tools and he used this all over the place, we optimized it. So it's now recognized that on the Boolean, this is fast.
All right, 1 down, 3 to go.
Wow.
I'll jump here.
All right, Kai's up next.
I'm yeah, okay, I'm all struck.
I gotta choose the screen. There we go. All right. So I will point out that Uiua also has like Uiua calls indices where. So it also has like the converting back to. It also has multidimensional where. And I didn't know about that encode thing. So here's Uiua's equivalent. Base is experimental, but it also has that. Here's the 3 at the end. That's not what I wanted to show though. I've got two little things. One is if I take a string like this, I've got keep, right? So keep is like replicate basically. But if I do unkeep, I get a run length encoding. And you can convince yourself that if you then do that again, it gives you back your original string. So the inverse of keep is a run length encoding.
Wow, that's
a fun.
Beautiful. RLE is one of the it's one of the things that
there we go.
Yeah.
One of the things that
Well,
but that's not what I wanted to show.
It's just really nice too because there's a relationship between RLE and what we'll call frequencies, this inverse where, because RLE Yeah. RLE basically
Yeah.
is a sort plus RLE equals frequencies.
I mean, Uiua has a lot of things like this because it can have functions that return multiple values, right? So there's some idioms of like, I don't know, if you undo a selection, well, a selection takes 2 arguments and gives 1 value. So the reverse of that would take 1 value and give 2 arguments. And here, this is just an enumeration of that thing. So if you need the indices of something, you do this, right? What I really wanted to show though was if you do a normal range, if I do keep 3 tens, I have 10, 10, 10. And if I do a range on that, you get your index generation, right? And then if I take this, I'm going to reuse 10 with this on modifier. You see, if I scroll all the way to the bottom, I've got 10 right here on the stack. And what I'm actually going to do is divide by 10. Now I'm going to have numbers up to 1, but decimal, and then I'm going to change this into 100. It's going to take a sec, and it's going to give you this nice colorful GIF because it says, oh, you have a 100 by 100 by 100 by 3 array. That seems GIF-like to me. I'm going to interpret that last axis because if I do the shape is 100, 100. This axis is colors, this is width, this is height, and this is frames. And there's an algorithm that converts the colors to quantized for GIF. So that's why it has like a Voronoi type image. That's a fun little thing.
How did you just stumble across this, or were you intentionally trying to
I
build
think somebody else, I probably stumbled upon it at one point. There's lots of fun things you could do with the GIFs. Uiua also has like built-in image constants, so you can mess around with image algorithms and stuff. Like if I type this, there's a picture of some cats. So you can do whatever image like things you want to do on this, right? So if I just did like reverse, now they're upside down.
Are those
Right,
your,
but
are
it-
those
it-
your cats? I did see a cat in the background at one point.
These are my cats, yeah.
Look at that.
Oh, I thought you would be
Obviously,
generating a new random image of cats that don't exist or
That would
something
be-
every time.
Yeah, there's my this is
I
the
mean,
equivalent of like a dyadic transpose.
can I steal that idea with the cats, because my cats
Yeah.
deserve more exposure on the internet as well. So putting them in as default data in the browser version would be trivial and amazing. I
You just have
need
to be
this.
aware that when you do that, is that people are going to turn your cats into like monstrosities by just like entering some code.
Okay.
Just
I will have to give it some serious thought, but yes, I need something like this. Right
can
now, I
I,
know what to do on the weekend.
We have no J representation here. Can I show an example from J of some
Sure.
cute thing?
And while he's sharing his screen, Elias and Marshall, do you guys have ones in the, what do you call it, the pipeline?
Yeah.
Yeah, I can do something a little bit. I mean, it's not going to beat the cat. I mean, but
That's not a language thing though. That's just like a fun little.
The
Easter
best
egg.
one was just typing cats and then poof, an image appeared.
Yeah. I mean, you do that and you won right away. I mean, seriously, if this was competition, I would bow out graciously.
So in J, this is a product.
What the heck
And-
asterisk is that?
That's what I think it is.
I don't know.
Oh,
that's a
I thought that was a special
font issue.
feature font. Okay.
Yeah, it's just a font issue. And if we take
Yeah,
the
so this is why BQN doesn't use asterisk use character. Yeah, we
Yeah.
will also use this.
and if you take the inverse of
Yeah.
a product on some number, then you should get some numbers that when multiplied together give that number, which are the prime factors.
Yeah, we will stole all these good
Oh.
ideas.
I mean,
I'm
That's a
very
good
much against this.
Isn't there also?
I have a factors function. I could do this, but
J also has a factors function, but I just thought this was cute.
I mean,
It is
but what if you have
incredibly cute.
234.5? Then what happens?
I don't
I
know.
mean, it's
That's a great question.
Well,
so it's like it's telling you it can't figure out new numbers that you can multiply to get 234.5. I mean, there's no way that's true.
I mean,
just turn the thing into a list.
So wait,
Yeah.
you said Uiua has this? Does BQN does? Or
Uiua
does
has this, yeah.
No.
No, okay. Because I was gonna
Marshall's too
say
principled for
this
that.
actually would be nice if you didn't have to spell inv.
No, I
Yeah,
mean,
in
we
Uiua,
can
it's just
spell it
gonna
out
use
like
the-
this. Right, this is just
And it gets
even
This
longer.
is
worse. That's even worse.
the power. Yeah, I mean, I don't like J spellings, but it's still a cute thing to do.
Yeah. I mean, was BQN the first language to add like the shortcut modifier? Because it's just so useful.
I think probably I don't remember any other examples having it at the time.
Yeah, and Uiua, yeah, so Uiua.
I took forever
that's
to
2
figure out,
characters. 3.
what primitive I should use for it because there were really not a lot of good choices.
Yeah. All right, who's next? With 2, what is that? 3 down, 2 to go, I guess.
Go.
This is honestly, it might be the best part of the podcast. So for the folks that managed to stick around the full 2.5 hours, this is also setting a record by far. And this is actually a shout out to, actually, Elias, you were the one that said, we want the 4-hour podcast. And now here you are basically like making, self-prophecy, what does it call it? Self-fulfilling prophecy?
yes.
So yeah, my example is a lot of people, when they want to work with digits of numbers, now this comes up most often in kind of recreational coding stuff, but it's also, more generally, it does happen when you have like, maybe not with digits, but with collections of data. So they'll take, they'll try to they'll take all the numbers and split them into digits somehow. And I mean, BQN doesn't provide a good way to do this. You have to, I mean, here I'm converting each number to a string and then subtracting 0. And then because that gives you a variable number of digits, I pad it out to whatever length I want. Actually, Kai showed a decent other way to do this, which is you just take, and it's probably better to do the number of digits and the base. And you can do iota on these together. But often what you want is actually something like the sum of digits. And so you could do this where on each number you sum the digits. But this is really wasteful because you're constructing a list of digits for every number. So the way I think you should really approach this is instead of starting out with this big combined thing, and actually this is kind of one of the reasons why I don't like having this combined iota primitive that takes a full shape, because it sort of encourages this approach. So what I'm going to write is longer, but it's also kind of more flexible and a lot more performant. So instead of starting out with this full list, you can instead move the iota over here and enclose it first. So you get the list of each, so you have the list of your tens digits and your ones digits separately. And then you can do a outer product sum across them. And so that only works with flat arrays, and it's much faster, but also you can manipulate the digits independently before you do this. So if you want like the sum of 2 to the power of each digit, you put the 2 power here, and then it's only being done once. And it works, it extends to any number of digits too. And of course, if you want it as a flat list, you just wrapple it. So you could even reconstruct these numbers. You would say, so 10 to the power of your base. We want to do these big Indians, so the 0 should be for the last, or the ones place should be the last digit and so on. So it reverse that. And then multiply these place values by the digits. And that'll restore all your original numbers, which I guess I can show by plotting. See, they go up in a straight line. You get so that's the same as iota 100.
You just needed decode here, right?
No, that's the point. You shouldn't use decode for this. You should instead use array methods. If you want to work with all the numbers up to a certain number of digits, or generally all combinations of things, you should start by thinking about array methods instead of thinking about decode, which is I mean, it's like sort of array-ish, but it's not really array-ish. Because decode forces, like, once you do the decode, you're always thinking about the digits of a single number. You're not thinking about your numbers as a whole anymore. So if you think about the list of all possible digits and that list for each digit, and then you're doing an outer product of all those, then you're into array methodology, and you can start, applying clever pre-processing to these lists of digits and save yourself a lot of work when you're computing. And you can also factor out some computations that are going to apply to multiple sets of digits. Like you could, if something depends on the first two digits, you could pre-combine those two digits and do some processing with those, and pre-combine the second set of two. So it's a really it's a much more flexible framework for dealing with all the digits.
Plus, who doesn't want to write an outer product reduction? I mean,
yep.
I think I've only ever done it once, but
I do it all the time.
It felt really good. It felt like, holy smokes, I'm already doing an outer product, which doesn't exist in basically any language other than array languages. And then you're combining it with a reduction, an outer product reduction. Like, it just you feel godlike when you're doing that kind of stuff.
I wrote an outer product reduction yesterday, and I was only working a half a day.
That he would have been working a full day, but it saved him that much time.
All right, last but not least.
Yeah, work smarter, not harder, right?
Mm-hmm.
All right, Elias.
Yeah, I was thinking about what to do. I have a lot of silly features but since Kai showed some graphics, I guess I'll do some graphics as well and demonstrate the feature that is has been around in CAP for quite some time, but not used. I'm not using it that often, and there are certainly. Anyway, I'll show you. Let's. Okay, do you see the screen?
Yeah, it's a bit small, but that's all right.
Small? Okay, let's make the font a little bit larger then.
Maximize the window, I guess.
No, I'm because I'm sharing the entire screen because I'm gonna open a second screen to put the graphics in. But let's make a 36, 35. Okay, now you can read this at least.
Yep.
I hope. So let's open this code that renders a Mandelbrot. So press Ctrl Return to evaluate the code. And now, let's remove that first to show the difference in performance. So we do, we calculate the runtime of running Mandelbrot demo. This is going to take a while because it's a bit slow, but let's make it. So here it computes the standard Mandelbrot, and it took I wonder why it took so long to actually give me the. Anyway, it took 11 seconds. That's not so good. So what we'll do here is that M is a function that calculates the 1 pixel. So so the way what the function does is it runs this on each pixel. So I can add this symbol here and then run it again. It should be faster because now it took 1 second only because now it ran across all my CPU cores. We can even show that here by.
That's very small for me.
It's too small. It doesn't really matter. I hope you can believe me that it runs on all the CPU cores here. I have 16 cores in my machine, so sorry, I have 16 threads, so it's 8 CPU cores. So it got about 11 times faster.
Yeah, it's using the same glyph as Dyalog has proposed for parallel but it does it differently than, because in the proposed thing for Dyalog is to write parallel each, not each parallel.
Yes. So what CAP does is that it actually it is an operator that acts on some function, and if that function is each, then it will parallelize the each. My thinking and something I haven't implemented.
If the function is a composition of each with an operand, that's what you mean?
Yes, I mean, because what M each derives a new function that is an eached function. And what the operator does is it looks at the function that it acts on and see, can I parallelize this? And right now, only each is supported. Now, my idea is to be able to do something like this. And what this would do is a parallel, essentially a map reduce. So if you put some arbitrary function here, this would then do a map reduce over a large set. Now, of course,
why is it map reduce? Isn't it just a reduce?
Yeah, well, it's true, but
where's the mapping?
Map reduce with
yeah,
map.
A parallel reduction, essentially, where you break it down into smaller parts, and then you can run the higher level, the second level reduction. You can run that in parallel as well.
You're telling it that the result will still be valid if you compute things out of order, right? In chunks.
Yes. So the function would have to comply with certain behavior. What is it called in maths? I can never get the terminology right. It's not associative, commutative.
Yeah, commutativity and associativity.
Yes. Well, actually, yeah, it has to be commutative, right? If it is, then it will just work. That's the idea, but that has not been implemented yet. But that's the that's the idea for the future.
I was going to say I tried doing that with like multiplication and addition, like making it do a map reduce just automatically, and I didn't find a speed up until you had like millions of elements.
No, that's right. That's why I demonstrated this parallelism by running it on a very slow function, which is and obviously doing a parallel reduction on plus is probably not going to be very efficient, or probably not going to buy you much. But doing it on a defun that is doing a lot of calculation, then it can probably be valuable.
But then, okay, so it analyzes and it sees, okay, this is an each function, and then it looks at how many processors do you have available and chunks things up, which means you lose, of course, ordering. Right? You don't know which order things will happen in, but supposedly you should only use this with pure functions.
Exactly. Yeah. You can specify the number of CPU cores it should allocate, but by default it takes the number you have on the machine.
It's an interesting, different way of doing it than what Dyalog the idea is where instead you do function parallel is equivalent to the original function, but will run in a different thread. So if you do function parallel each, then it will make one thread per element. But that leaves it up to the programmer to chunk things in a proper way, because you might create 10,000 threads, which is not very good. You really should only create like as many as you have CPUs, or twice as many, or something like that. Maybe minus a few for this system to do its thing. So this allows instead the parallel operator to do its best guess at what will be good to do.
Yes, and it's obviously, I mean, I can imagine cases where this is not ideal. It chunks it up. It calculates the size of the chunk. Actually, the chunk is, if you have 16 cores, it doesn't chunk it up into 16 pieces. It chunks it up into smaller pieces and queues them because
you don't know how long time they will take.
Yeah. But so it uses some heuristics just to decide some. I can't even remember what I picked. But it works decently well for the test cases I have, but there's no way to control. I was thinking about adding axis parameter to the parallel operator, and put configuration parameters like the chunk size and stuff in there. I could do that if need arises, but I right now it's just does its best. and for
Jay
something
also
like
added a parallel operator like this, but it's a dyadic operator after inspiration from Dialog's proposed monetic one, and so it has an operand that I think can only take currently one value, so it doesn't really do anything. But for this purpose, that in the future you might want to specify exactly how do you want this done. And there's a whole bunch of other stuff you might want to specify. For example, I don't want this to actually be computed here. I want to be computed on some super cloud computing thing, and you to be able to tell it where to do it.
Yeah, I think K has a parallel each that is literally the each parallel that I implemented that does the same. I think it was mentioned on one of the array casts, but I didn't try it because I don't have K.
Yeah,
And,
K4 definitely does, or K, whichever KX's K is. I think that's K4.
Yeah,
it has something
I
called
think
each, right?
Yeah, exactly.
Which you would,
and that sounded very close to what I have. Yeah.
Yeah, and Dialog has a parallel, no pun intended, parallel to this with the ampersand operator spawn. It doesn't do OS threads. It does what you call in Java green threads, but that allows you to do concurrency by spinning off threads to do things. And there you write spawn each. So it's just so f spawn is the same thing as f, but will run in its own thread.
I mean, that means that you have the necessary building blocks to actually build. You can build in Dialog. You could write some kind of dispatcher that handles all of this for you, right? So
it already exists. It's already
exactly.
It's just experimental, and it's in a workspace with some comma functions, but really boils down to some crazy I-beams that does this because we haven't assigned it we haven't hooked it up to the symbol. We have the symbol for it. We know the keyboard location where the symbol would go, and everything is implemented in the interpreter. But you currently use a cover function called LL. It looks like two vertical lines, lowercase l's, or uppercase I with two dots on top of the I. So it's the parallel each kind of thing. But everything
I
is
was
there.
not aware of this. Okay, I need to play with this. Okay, I'm gonna ask you later how to use it.
It's just a workspace called isolate. You can just copy that workspace or load the workspace and find instructions for it. The isolate workspace.
Okay, you learn something every day. Okay, I need to look at this. Thanks.
And that one there's such a thing as creating an isolate separately and then running things inside that isolate. And there it's simple to create an isolate on somebody else's computer, and then you just run things over there.
Neat.
Well, you say you learn something every day. I learned about 10 or 20 things. Probably like every single one of the things that were shown. I don't think I knew a single one of those. So goal achieved in showing. Yeah, like I said, I don't want to call them tricks, but like, yeah, maybe idioms is a better name. But yeah, still, I'm still sad that the iota underbar iota, I missed that. But anyways, thank you so much. I think this has almost gone twice as long as the time that I blocked out in folks' calendars. But I guess maybe going forward, when we try to do these again, if folks are interested, we will block off more time. I'm not sure we'll ever hit the 4 hours. We'll probably try and keep it less than the 2 hour, 47 minute mark that we're at right now. But yeah, thank you to all of you. And yeah, hopefully we didn't keep you up too late, Elias. And I guess it's gotten just...
It's not even 1 o'clock yet.
Yeah, I mean, usually I'm in bed by that time.
Thanks for putting this together, Conor.
Yeah, no, this is it's been a blast, and hopefully we'll be able to do maybe not every month, but yeah, hopefully going forward. I put the number 1 there in after the implementer panel, in hopes that we can do this every once in a while. Because yeah, these are, how often do you get to talk to 4 different language implementers? Yeah, I think that with that, we don't have a sign off. It's Tacit Talk, so I'll just say thanks again for coming on. And until we do this again.
Thank you.